educates, inspires, and drives progress in the industry by seamlessly blending the formats. And I implore all of you to please use your time over the next 2 days, very improved design, construction. Welcome Mr. S.K. Puri, Executive Director, ICT Private Limited. Mr. Suresh Kumar Puri is the Executive Director at ICT. He holds a bachelor's degree, BTech in Civil Engineering, and invite on stage our speakers for this session. Please welcome Mr. G. Prasuraman and Mr. Abhishek Tiwari. Please give a round of applause and welcome them on stage. S.K. Surves. And please welcome on stage Dr. Bhavesh Jain and Mr. Tony Matthew of TRL Technologies Limited. Tony Matthew.
Good morning, everybody. A lot of emphasis on that, and in the budget, almost about 3 lakh crore per year in the highway sector, and almost same amount, 2.8 lakh crore, to the from planning to financing models, and the implementation is one part, and then management, that is operation and maintenance.
Of road network using technologies such as network survey vehicle and falling reflectometer. In today's environment, reliable and high quality data is the foundation of everything at the right time and place, enables effective asset management decisions. Timely and targeted intervention improve road performance, enhance safety, and significantly reduce life cycle. So this is where we are going to get knowledge from NTRO, go into the other fields like ports and the other sectors. And this is about IRSM. We have a corporate, our registered office in Chennai and corporate office in next. And these are the different types of measuring devices we use for road condition assessment. And I will ask my colleague Mr. Tiwari to briefly explain how
to the topic of asset management. For the asset management, obviously the context and keynote is that asset management is a basic tool for any asset management system. Is obviously this is the cycle which everyone knows about it, how to maintain the road network, and there's a cycle of. So for all that to happen, the quality of data is foremost important. Like you see in this presentation, every road net assessment is a basic parameter for any payment management system. So in payment management system, roughness is more like basic parameter which has to be ensured. Just measuring the payment with one standard vehicle or standard devices which will give you the basic information. Then all the repetition and performing the condition assessment with different devices and repeating those sections with measurement tools is the process, obviously, which I mean, generally for 10-kilometer stretch has to be identified, and then we have to keep validating that stretch, and then obviously the different vehicle can come and perform measurement. So obviously there's a method that Australia adopts. They have identified one particular section, and NTRO is a body who validate that stretch and give us a.
So now our second speaker is Mr. S.K. Surase. He is the Chief Engineer in Maharashtra State Road, accomplished road sector technocrat who has played a crucial role in design and development of Greenfield Expressway, Mumbai, Pune, Ahmedabad, Vadodara, etc.
This missing link project, so is a challenge in engineering, so we'll go one by one. So why it is an engineering challenge, you can see from this photographs. So a lot of hairpin bends, everyone knows this Lonavala Ghat. So even this, due to environmental constraints, the project could not take up for the straight length originally aligned. However, we made Mumbai-Pune Expressway LK bypassing link was to be taken on priority. Next. So these are the some silent features of the project. So it's a 19.8 kilometer existing length of Ghat length, so which has been reduced. Construction of 2 viaducts, including 1 cable stayed bridge in this package. Second. Next. Below Lonavala Lake for a length of about 3 kilometers. And its depth is ranging from 150 meters to 180 meters below Lonavala Lake. This was the challenge. We were feared that some leakages may happen or so. So then even there was also issue. So we all met these challenges during execution. Next. During construction of viaduct, that's cable stayed bridge, there was a wind pressure maximum up to 77 km per hour. So even heavy monsoon in Khandala was also the issue in the prolonged period for forest areas. Then access to water was also challenge. Non-availability of skilled manpower. Then even 10 manpower also left the site, conducted at abroad we discussed. Then getting clearances from forest used in valley area. Then deck concrete was done with cantilever form travelers used for deck casting for 9-meter length either side of the pylon. And specialist subcontractor was appointed for completed one. Second cable stayed bridge is 97% completed, and the entire project will be completed within coming 2 months and will be open to traffic in April. This is the cross section, widest tunnel of 23.5 meters. So which has been provided with all latest technology, including water mist. Next. This is the viaduct completed. First, next. This is also viaduct completed. Next. This is under construction, which will be completed within coming 2 months. Next. These are the photographs. Next. 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 Next.
Thank you. So our next speaker, the 2 speakers from TRL Technologies India, Dr. Bhavesh Jain, who's a
safety, decarbonization of transport in over 100+ countries. Now we have a global footprint of 100+ countries. GRIS do this largely through political means. That's politics drives road maintenance in a way. But it is a requirement now for emergers. Asset management of fixing bad roads or trying to do exactly that, not just doing road maintenance, not just fixing bad roads, but to ensure that their road network are climate resilient.
Thank you, Tony, and good morning, everyone. I'll start the process of its design life. And on the top of it, if we add in maintenance strategies in more systematic and cost-effective manner. It brings all the data, road inventory, to take decisions to manage the asset performance, integrating with hazard exposure and enabling predictive maintenance rather than the reactive maintenance. Resilience in RAMs helps you to take these kind of decisions. So now I'm going to introduce TRL's climate-informed RAM solution, which can integrate with other systems as well. And it provides a platform for multi-assets, not only roads or pavements, but bridges, drainages, signages, and Bangladesh. So you can see different demographics, geographics, and climate variabilities everywhere iRoads is being implemented with different level of maturity among the road agencies. So coming back to the case, yes, sir. So I'll just switch to the, so this is the interface of iRoads platform for Kerala. You can see the entire road network on the southwest belt of India, Kerala state, and SG or the framework which was incorporated into iRoads to implement this solution, bringing hazard, vulnerability, and exposure together to calculate a to do the risk assessment for the road network. And the steps are like this. So we, like I said, risk-informed maintenance. By bringing climate resilience module in this, we were able to identify the sections to the public users better than the road agencies. So we need to bring them on board to fight against these challenges which is caused by the climate change. Thank you.
Thank you. So for conclusion, I would like to thank Vision for Countries Infra Growth. He presented the importance of accurate technology-driven data for robust. The efforts put up by MSRDC to overcome the challenges were also explained. The project will be open in next 2 to 3 months to the traffic, so for a long-term sustainability. With that, I would like to thank all my colleague speakers, and thank you very much.
Please gather for a group photograph. We shall now begin with the first plenary session of this conference. India's Vision Zero aims to reduce based on the principle that road systems must be designed of experience in Internet of Things, urban mobility, vehicle-to-infrastructure communications, and cooperative, connected, and automated mobility. He has made significant contributions to the field and has collaborated with industry leaders, government agencies, and academic institutions. Gonzalo Alcaraz. I would also like to invite on stage our speakers for this session. Please welcome. Rapporteur for this session is Dr. S. Deepa of CSIR CRRI.
I'm happy to be here opening and having the privilege to be with you at the Global Road Infrastructure Summit and Expo 2026 in New Delhi. Actually, it's my first time in India, so I'm happy to see with my eyes what's happening in this wonderful country. And I think that a lot of young people is affected by this. At the same time, our sector contributes to a large number of portion of CO2 emissions, around 25%, and placing road infrastructure as one of the major contributors to that, around 3% of the GDP on an annual basis. Along that, safety, of course, and system accountability. Similar things happen as well in the Netherlands, for example, where the concept of an infrastructure that forgives human error, expansion of the public transport can lead to substantial reduction in emissions and pollution, and improving the safety and efficiency of the whole network. So we are at this point on how we should be going forward on the pathways for this. First, we need to improve safety by design So integrating road engineering, vehicle artificial intelligence, data platform, connected vehicles, and intelligent traffic systems that can research, the academic sector, work together as a unite group on pushing forward this. And I think this summit will represent an opportunity for that, and I'm counting on you. Mr. Sitaram will be talk about sustainable infratech for transformative change in India, Vision Zero for safety and carbon-free developments. Please.
Technical education in India today is about 44% women. But unfortunately here very few are there. Maybe it is dominated by the men. Structure, particularly the last one. But current investment levels are well short of what analysis say is required for India to sustainably scale up to a global top 3 economy. We are now top 5, and the estimates are by 2028 will be in the top 3 countries in the world. So for that, infrastructure what we have built is not enough. That means India is yet to be built. I think this, all traffic fatalities and severe injuries based on the ethical principle that no loss of lives is acceptable in the transport system, shifting responsibility from road users to system designers. See, so far we were only talking about, oh, in India road behavior is no good. It's a mixed traffic and a lot of problems. But my own story, when I was a professor at Indian Institute of Science, we started a new center called Center for Infrastructure Sustainability. That center was trying to interlinkage all these aspects what I've highlighted today at very early. A lot of work has been done in that direction. Concurrently, centric transport network that reflect the very objective of this summit. So I'm very happy to see the summit had the vision, having Vision Zero. Friends, the Vision Zero and carbon-free impacts every day. This is a very serious issue, ladies and gentlemen. With speeding contributing to nearly 70% of these fatalities, it is attributed to speeding. And non-use of helmets and seat belts causing roughly 39% of the deaths. Underscoring the urgent need for robust design and of India's decarbonization and sustainability agenda. Friends, Vision Zero and carbon-free development across the world, and particularly the Vision Zero, is reshaping transport policy of the nation, aiming for zero fatalities and serious injuries on our roads. India has embraced, we need to rethink when we build large projects, because everything what we are building today is a very large project. Sustainable infratech is exactly that, designing systems where safety, durability and decarbonization are enabled. Monitoring and circular construction practices, we can achieve this goal much more efficiently. Indian engineering community is now omnipresent in a constructed Chenab Bridge, one of the highest elevated rail bridge across River Chenab, is one of the classical example, if some of you have not seen it, witness that, which not only the engineering marvel, it connects, must achieve, that is engineering excellence married to environmental prudence. It's a pursuit of sustainable mobility has taken an innovative turn with another classical project, Kochi Water Metro, so which is one of the cheapest and very well done indigenously, Atmanirbharata. The metro system in the water has been designed and developed within India. For energy-related emissions, India's response is very bold: build faster, but build cleaner. So another very important project is close to all of our hearts, which is Ram Janmabhoomi Temple. I think I have to mention that, because this temple is not just a mere temple, ladies and gentlemen. This is an infrastructure created on the hopes of 140 crore people. The Ram Janmabhoomi precinct in Ayodhya demonstrate how heritage, sustainability and modern construction technology can coexist. Energy efficient planning, water sensitive urban design, durable local materials and crowd safety first circulation systems have been part of this project. This community of policy makers, contractors, financiers, researchers, and technologies commit to, what we should be doing. Let me suggest 5 imperatives before I conclude my talk. Design for the infrastructure industry to invest on people. People is the key. That's where the human capital will rise. Skilling engineers for sustainability and safety engineers who are going to be the engineers of the world on sustainability and generations to come. Thank you very much for patiently listening to me. I wish the GRIS. Jai Hind. Namaskar.
Strategic enable for Vision Zero India. And Mr. Gade, he's the founder and CEO of Deacon Complete Solutions. He's a senior professional with a rich experience of nearly 4 decades in a number of topics, including construction.
And also to my talk, to be honest, like that, mine is going to be a little bit more technical, in nature, because I'm basically a technical man who has not occupied any high positions in the government organization like Dr. Sitaram, so that he can eloquently speak about any subject so beautifully. And he has set a very good context to my talk, as I told you, that nation which dreamt big, or whether it's a nation which built big. Obviously, the answer is, resilient and carbon neutrality oriented. That means Vision Zero growth. That's what I'm going to talk about. And all of us are aware that the 4 pillars of the infrastructure: energy, water, sanitation, urban development, ports, aviation, digital infrastructure, bridges, and mega structures. In fact, I think our Sitaram mentioned about the Chenab Bridge. Similarly, there's a Atal Tunnel, MTHL, Namaste Signature Bridge in Delhi itself. So there are so many. Tremendous growth. Like if you look at the roads and highways, 0.4 million kilometer, which was there in 1940, unprecedented 1947 to 2025. But it was all physical, as well as the economical development was the thrust on that. But when we are going to celebrate independence in the infra. Now, what is this Vision Zero we are talking about? Basically, let's understand that. As all of us know, there is an increase in the carbon dioxide concentration in the environment that leads to the increase in the global mean temperature. In fact, the global mean temperature increase is the measure of the carbon dioxide, which has been emitted to the environment, concentrated in the environment. Manifestation, as you can see here in this, all of us are, is the production. A0 is nothing but the preliminary studies which we'll be sending. In each these stages, whether it's before the use stage, in use stage, conventional life cycle cost is only an economic cost. But when you are talking in the future, taking the sustainability aspect into consideration, it has to be integrated, as you can see here. Also during the in use stage and after the service, the end of the life, it has to be deconstructed, transported, processed for the reuse and disposal. And all this happens in the life cycle of an infrastructure, and it creates the carbon footprint, and also it creates the concept which has been spoken quite a lot. All of you are aware of in each and every seminars these days. The circularity concept is nothing but at the end of the service life of any infrastructure, if there is any residual value of the life cycle. So the circularity as well as the life cycle concept has to be looked into in conjunction. I talked about the cost which has been created over the life cycle concept, as you can see here. Normally, up to for the maintenance, again, operation, maintenance, and other things, again, there will be a economic cost as well as the carbon footprint created during this before the use stage is around for 50%, including the completion, as you can see here, 38 to 60% during the service stage, that the in-service stage, end of the life for the deconstruction, etc., it's around 2%. So that's how integrated life cycle cost. I think going forward, if you have to achieve the vision zero, this is the only way to make it mandatory to have the procurement, all the procurement models, procurement processes to be based on this integrated life cycle cost. That's the only way, in my opinion, the carbon footprint, monetized carbon footprint, also such residual input credit, you can get that. That's how it is. Then discount rate is, there are two types of it. One is the real discount rate and the nominal discount rate. Real discount rate is adjusted for the inflation, whereas the nominal discount rate is normally it is includes the inflation, as you can see here. There are many guidelines on which basis this discount rate can be assumed, but for a long-lived infrastructure frequency, decreased precipitation, severe frequency, cyclones, change in relative humidity, higher precipitation, all this gives rise to the risks, as you can see here, which has been there in the peripheral of this infographic model. As you can see here, all these effects will result in flooding, material degradation, severe accidental load risk, extreme natural event risks, operation 030 and 2040. Finally, from 2040 to 2047, that is when we Independent Day, 100 years Independent Day, we are celebrating in the Viksit Bharat. I think we have.
Thank you. Thank you very much. I think due to the lack of time, if you have any questions, perhaps you can take it over lunch or over the next 2 days. I think we got a lot of inputs on what is going to be the next decades for India, and I appreciate.
Thank you, gentlemen. I request you to please stay on stage for a minute more. And I would like to invite on stage Mr. Kapila to please come up and present our speaker. I request all of you to please gather for a group photograph. I request, and I'm sure very soon we'll have more attendees as soon as they wrap up the tea break, coffee break, a visit to the stalls. But in the interest of time, we'll start seeing the presentations. In our first technical session, the topic is digital transformation of highway infrastructure through asset management. Technology turns roads and highways from passive infrastructure to intelligent, self-reporting assets. Sensors, drones, AI. Please welcome the session chair on stage with a round of applause. Please welcome on stage Professor A. Veeraraghavan, former professor, IITM. Professor retired from, as a professor in civil engineering from IIT Madras. He has over 44 years of experience in teaching and research. He's a member of several technical committees of IRC. He is a member of, he has published over 250 papers in journals and conference proceedings. He is the co-author of 5 books on civil engineering. He's a fellow of the Institution of Engineers India and a fellow of the International Society for Engineering Asset Management. Please give him a round of applause. Now I shall call our presenters on stage. Whoever is present may please come up on stage. Please welcome on stage Rishish Jha, who will be having a presentation on smart asset management for road networks. Please welcome on stage Faiz Ali. He's going to be talking about iRama, Intelligent Road Asset Monitoring and Assessment using Edge AI. So I request the speakers who are here to please come up on stage. Please welcome B. Divya. He will be presenting on, he'll be doing a technical audit and grading approach in enhancing highway infrastructure. Please welcome Ayush Kumar. He'll take us through an effective role of a non-nuclear density gauge in SMA layer. Please welcome on stage Mr. Pradeep Kumar. He'll be talking about a data-driven road asset management framework with a case study. And please welcome Ferguson Polsey. He will be talking about Namibia's road management system. Please also give a round of applause to our rapporteur, Dr. Sampath Kumar of CSIR CRRI. So a round of applause for all our speakers. A gentle reminder to all our presenters, the time given to each of your presentation is about 10 minutes. So I request you to please wrap it up in 10 minutes and be mindful of the time that you're taking when doing your presentations. I will hand it over to the session chair, Professor A. Veera Raghavan, to take this session forward.
Thank you very much. Distinguished speakers for this session and the distinguished delegates. It's my pleasure to chair this session on the digital transformation of highway infrastructure through asset management. To give a brief introduction about the topic of this session, this digital transformation is expected to improve the efficiency or enhance the efficiency of the performance of road assets, enhance safety, sustainability, as well as financial performance of this highway infrastructure through digital-driven planning and life cycle cost so that we can develop a decision support system. There are several issues in this context. India has got a very large network of nearly 6.6 million kilometers of roads. The traditional maintenance practices, that's what we have been doing all these years, are ad hoc, thumb rule based, and it is fragmented. This has resulted in increased life cycle cost and also increasing the life cycle cost of this payment system. So we do hope by this digital transformation, it will enable us a systematic monitoring, evaluation, optimization of the highway asset through an integrated platform which will enable us to develop a decision support system. There are a few key components in this digitization process. It starts with digital asset inventory and GIS mapping. Secondly, automated condition monitoring. Third, use of the data in performance prediction, development of a pavement management system, a bridge management system, and integration of BIM, GIS, asset management system, analysis, application of AI and ML, and the dashboards. There are several strategic benefits of this digital process which we are going to listen from the eminent speakers. Mainly, it reduces the life cycle costs through proper and timely assessment of the condition of the infrastructure and timely implementation of the maintenance measures. Secondly, riding quality enhances, low failures, premature failures, improved transparency, audit-ready reports are possible, early detection of the safety risk, there will be an optimized material use and reduced carbon footprint. So there are several issues, implementation steps in this process. It starts with the asset inventory. Second starts the digitization. Third about integration. And lastly about the intelligence applications. So we do have a list of 6 eminent speakers in this session. The first talk is by Mr. Rodik. Rodik is not here. Right? He's not here. Mr. Rodik is here? He's not. Yeah? Is he here? No. Okay. Let me go to the next talk about Rama, Intelligent Road Asset Monitoring and Asset using Edge AI in real time. We do have speakers, Faiz Ali and Dr. Indrajit Ghosh. Indrajit Ghosh is a professor from IIT Roorkee. He has an extensive experience, especially in the road safety issues as well as on road asset management. Now, may I request Dr. Indrajit Ghosh to present on Intelligent Road Asset Monitoring and Assessment using Edge AI in real time. Over to you, Mr. Ghosh.
will open. iRama. So thank you, sir, and good afternoon, everyone. So I am Indrajit Ghosh, currently working as a professor in the Department of Civil Engineering, IIT Roorkee. So this is our presentation, iRama.ai. This iRama stands for Intelligent Road Asset Monitoring and Assessment. So Faiz Ali is the project associate, who is basically the first author of the paper, and I am the second author. This is a part of the project which was sponsored by iHub, which is known as Mini DST. So we are grateful for them to have a trust on us, and they have been spending good amount of money for the development of this framework. So we all know that we lose life because of road traffic accidents. Many of the accidents are attributable to the bad road condition. So if we look at the existing road traffic surveys, how they are being collected, so some of them are really reactive, some of them are really time consuming, some of them are really expensive. So overall, we see that there are various technology which are available, like vehicle-based, then network survey vehicle-based. So when the cost is very high for like the network survey vehicle, it is not possible to go for road asset management at frequent interval. So what do we have? We have the data of a particular road at the interval of 6 months or 1 year. So what we have done, that we are trying to build India's road health infrastructure system, and this is just not a camera system, what most of the people are doing these days. So I will show you what we have been doing. So basically, our aim was to digitize our roads through AI and edge computing. And second is that we try to get real-time data with geo-referenced information, and we will have it at continuous, like on regular interval, so that our data is continuously getting upgraded. So we thought that our aim should be from manual inspection to the intelligence monitoring. So this is the framework of iRama that I have been talking. So edge AI detection, then geo-tagging, then from them we are getting everything on a particular dashboard. From the technology stack point of view, we are strategically at a very good position. We have edge, we have AI, we have data, we have API, we have thought about the business. So here you can see that we have used some of the edge computing devices, which is known as NVIDIA GPU-based edge processor. We have camera, this display, we have SIM connection, okay, and these are some of the key features. So we are getting data, real-time data at 10 frames per second, and continuously data is synced. Yes, there are certain locations where we do not have mobile data. So whenever the mobile connection will be back, so the accumulated data will be sent to the cloud immediately, and finally we will be able to see it in our lab, where we have the dashboard. So from the camera point of view, in order to make the database really robust, we place the camera at different locations, not only at the dashboard, in front of the dashboard, like outside the vehicle, side of the vehicle, top of the vehicle, and we try to train our model, the machine learning model, so that any photo you show, it will be able to tell that this is that. So this is what it is. Then from the user interface point of view, you may be able to see that there are a number of models which is given here. So drop-down menu, there are a number of models. We can run all the models all together, or based upon the requirement, what a particular agency, smart city or PWD wants, we can run individual models. So we have the option for the customization. The first point, automatic boot up, is basically as soon as the vehicle start, the system starts automatically. So it will continuously start capturing the information. So here you can see that here is a live preview which you can see like what is going on. So as I told earlier, there can be real-time data or there can be data that is being transferred to the cloud on certain interval. So we have collected data from 800 plus kilometer. We have data from Roorkee, we have data from Saharanpur, and we have data from the city of Kota, which is in Rajasthan. So our detection accuracy ranges between 80 to 90%. So you can understand, those who are familiar with the technique associated with the survey, that when the vehicle speed is comparatively small, less, then accuracy will be high. When it is high, then accuracy will be comparatively low. So we have tried several runs, as I said, 800 kilometer. So 50 to 60 kilometer range, it is more than 90% accuracy. Now when it is traveling at the speed of 90 to 100 kilometers, so we have made multiple runs between Roorkee and Delhi. So we found that it is coming at the range of 80%. And as I told earlier that our like we are getting data at 10 frames per second. Survey coverage per vehicle can be 250 kilometers per day per vehicle. But we made number of runs where we started from Roorkee, ended at Delhi, and Delhi to Roorkee. We came on the single day with all the information. So from the technology readiness level, we can say that our product is at 7. So it is at market ready condition. Yesterday only I pitched for our startup for the commercialization in front of IIT Madras people. So they have a center for data science and artificial intelligence. So there were jury from startup companies. There were people from IIT Kanpur, IIT Hyderabad. So I pitched our product and yes. Now, there are 15 plus type of road asset component that we are capturing. So as I said that we are relying upon edge computing, so everything is being done at the device level itself. So what we can get? So we can get this stress-related information. Pothole everybody is doing, even computer science people are working on pothole. But I thought that how we can use our civil engineering knowledge. So opened IRC code, we found that there are many guidelines related to different types of cracking. So alligator cracking, longitudinal cracking. So everything we have included here. Then we also thought that when there is no pavement marking, sometimes the people cannot go for the lane discipline. Like we have seen when we had Noida, Greater Noida Expressway, and we did not have lane marking. People were traveling at a very high speed. I found that that kind of driving condition is really pathetic. So if we have lane marking, then it is good. So we can also identify where we have faded pavement marking. Then also we can identify sign, and not only sign, we can do the classification of the sign. With the civil engineering knowledge, we can classify sign based upon whether they are warning sign, mandatory sign, or informatory sign. We have also looked at the crash barrier and guardrails, because when we visit the hills, we have seen that there are many places where the accident took place, where the crash barrier fell off the vertical post. And obviously on the national highway side, you will be able to see some guardrail which got hit by a car or a truck, which is completely bent. So we can measure the length, how much it has fallen down, how much it is damaged. And lastly, we can do some post-processing in our lab. So post-processing is in identifying the anomalies or problem. What is the problem with the sign? What is the problem with the crash barrier? Those we are doing as a part of post-processing. So here are some videos, snapshots. So here you can see this is a really small pothole. This is a large pothole. This is on the other side of the lane. So our vehicle was moving on the first lane, which is closer to median. So we can see on the second lane, sorry. Then we can identify the alligator cracking. We can identify the advertisement board. Many a times when people, the undergraduate students try to develop something based upon sign, their machine learning model falsely identify the advertisement board as a sign. So we have specific model which will be able to distinguish between sign and the advertisement board. And the other thing I forgot to mention, people talk about privacy AI, like we don't want to disclose the information of the people. So we have automatically made in such a way that all the vehicle, all road user, whether it is motorcycle, car, pedestrian, will make them blurred because we do not need any information related to road user or the vehicular number plate. So that we have done. So here you can see we have the dashboard, we have mapped it properly. At beta stage, we are trying to develop some model which will be able to tell us what is the area of the pothole and the volume of the pothole. So 100-kilometer road, 70 pothole we have, all the undergraduate students, they are working on that. But from the civil engineering point of view, we understand that there is a difference between severity 1 pothole and severity 3 pothole. So which one has to be fixed first? How we can have efficient use of the public money? So that's why we have gone for the classification based upon the area and volume. Also, we are trying to develop some kind of app where citizens, they will be able to take photo and send it to our server. So at IIT Roorkee, we have done multiple runs and trying to show the different kind of condition that we have for our road assets. So we have made multiple runs because we made sure that same pothole is not getting detected multiple times, and also we are trying to see how our road asset has deteriorated or has improved over the time. So these are some of the information. This is the video. So if you people are interested, you people can check that. So these are some of the snapshots. So basically we are going to the same road at frequent interval so that we don't have to wait for 6 months or 1 year, just like we do in case of the network survey vehicle. Next slide. Why it is not changing? Okay, now as we are academician, we have the backing of IIT, so we were really privileged to file some patent. The first one was related to system development. The second one was related to volume estimation using the single camera. We have filed the patent so that no startup can copy us. And we have some of the publication which has been presented at different national and international level. So you can understand we have the technical credibility. And we have also thought about the business. We are thinking about the commercialization B2G, business to government, and B2B. So like whom we can sell the OEM, whom we can sell the data sets. So we have already thought about. So this is the roadmap, what we have been doing. So we want to transfer the accountability to the people who are responsible for the maintenance of the road. So that we have been doing. And lastly, I want to say that Indian government is spending huge amount of money for the maintenance of the road blindly. Like they do not have much idea where the pothole are, which crash barrier has gone bad. So we have a data-driven approach. So we can take some proactive measure and we'll be able to make our road the best road in the world. Thank you.
Thank you, Dr. Ghosh, for this interesting presentation on the intelligent road asset monitoring and assessment. We'll discuss that further. Let us say here, I think Mr. Rashish Jha has joined. May I now request Mr. Jha to talk about the smart asset management for road networks, digital transformation from legacy systems to intelligent networks. Over to you, Mr. Rashish Jha.
Good afternoon, sir. Thank you for giving me opportunity to present my paper, which is mostly based on case studies which we have implementing ourselves in the state of Bihar. And also a lot of numbers are used in my paper, which has a backup of almost 4 to 5 years as we are implementing it. Some of the intelligent road asset management, yeah. I have a presentation. No, it's not there. Okay, it's there. Yeah, it. Okay, sure. I can't see here. It's many. Can't I see in this? No, I can't see in this. Yeah. नहीं आ रहा. Yeah. So India's road asset management faces a critical inflection point. Legacy RAM system consisting of periodic visual inspection, time-based maintenance, siloed database cannot manage 6.5 million kilometers under monsoon stress and climatic changes. The paper presents a digital transformation roadmap from reactive system to intelligent predictive asset management networks. Using Bihar's output and performance-based road maintenance contracts with AI ML assessment validated by NHI and other PWD, some of the PWD in the country, the paper outlines, we have now. Yeah, the paper outlines basically in the sixth heading, we're talking about the transformation imperative, how we have gone through. Then we have intelligent network architecture, what we have done for Bihar state, and then proven OPRMC. That records also I'll try to take you through quickly, and pan-India validation, how we are planning to do. Actually, this paper was supposed to be presented by Mr. Narendranath Sinha. He is the main author for this paper, and he's ex-secretary, but he could not make it, so I'm just representing that. But it is his vision, how he's planning to transform as we learn from our ongoing Bihar OPRMC project. So yeah, exactly from reactive maintenance system to predictive AI powered. So what important point we are seeing is that average PCI for most of our roads, I'm talking about most of this paper is calculations are based on 6.5 million road network. And that's what we are projecting in the national rollout plan as I'm in this paper. So we have we know that periodic, I can't see also this. Anyway, let me go through my paper. Yeah, exactly. So periodic condition survey conducted only within 2 to 5 years, which generally legacy PWD does that. We have been doing historically. But now with subjective assessments are generally done where the PCIs are still manual based, which is being now machine learned now. And then we have reactive maintenance, maintenance generally adopted. I'll just now why transformation is urgent. Scale demands automation, technology maturity has already achieved. National proof points are available. Now that we have started, I'll take you to basically the Bihar OPRMC. The key insight here is it's no more operational, it's now going to be exceptional. The integrated technology assessment, intelligent assessment management. So these are the 5 steps which we have tried presenting in the paper. These are automated condition assessment, predictive analytics, IoT sensor networks, and digital twins. Then the next phase is that federated data flow, how exactly platforms we have used as a projection. Now this is important case study which we are implementing for last 3 to 4 years for Bihar. And this is where for learning has come from this project, and our own team is working on this. And it is output performance and performance-based road management system, how it works and what we have learned. And this learning is what been used to project the paper. So total 2013 OP-RMC scheme started by the Bihar state government, wherein 9,000 kilometer of state road MDR was selected for maintenance, OP-RMC, basically output and performance-based maintenance. In that, then next phase was 2019, wherein 13,000, 9,000 plus additional 5,000 was added for the project. From 2019 onwards, in 2000 till 1918, it was mostly paper-based system wherein engineer has to go and collect data and then come back, make a paper. So in 19, Rodic Digital Company was invited by the Bihar state government to digitize the whole process, integrate whole process. And that's how we have then created a central command center, created a Rodic own web-based maintenance system, and also we have an app-based wherein these data are real-time collected for the site, and then the workflow is mapped wherein every damages or every damages are automatically sent to the concerned allocated engineers, government engineers, contractors, real-time, and then these are attended to within given time frame. SLAs has been defined, and the payment to the contractor is based on how quickly he attends to those damages. Now, good part is that, I'll just take you. So now, next milestone, which we are now, the government is looking into is using AI. That's the next phase, 2026 to 31. Next phase, they want to cover all state highways, 19,000 kilometers, wherein they're going to use AI/ML based. Now that we have sufficient data, these data are now being trained for AI/ML application. So this whole process becomes henceforth automatic. And that's how, which most of the companies are selling these technologies. But this is what we have already experienced, and now we are working on that. We have started implementing in the state. These numbers are very important. I think I have all backup calculations. If anyone interested, I can prove how we have worked on these numbers so that it becomes easy for state government to adopt these numbers. How we plan to pan-India validation, how exactly we are planning to do. This also I have covered in the paper. I think detail can be read through the paper because these are very specific to state governments, what they have done and what learning we want to further take it to larger road networks. What level of accuracy, these all informations are detailed available in the paper which we have presented. Next important thing is that this also, what we have learned from this 20,000 kilometer of work done in Bihar is being now extended to rural road as well, wherein rural roads will also be monitored through AI/ML applications. And this is what this plan is, how the state government, central government and state can implement this learning which we have already done or which we are projected for Bihar. These numbers again, how much we have saved, what is the cost, all is the output of actual work done in the project. So these numbers have come from there, and also we have compared this with international experiences and then concluded these numbers are well acceptable by state authority to go ahead further and start implementing the project. So what we are going to get in next 5 years, say 2026, we're going to use this. So that also projection we have given in the paper. Detailed information has been given wherein what is the saving, what is the life cycle cost saving, everything has been well calculated. And yes, the accident reduction, all that data are available for support your decision making to implement in the state, at state level. So basically, yes, the India's road asset management transformation is no longer optional. We have the capability, technology, and framework to scale intelligent asset management across 6.5 million kilometers of roads. The question is not whether to transform, but how quickly we can deploy. So that's the theme of the paper, and all numbers we have presented well. One important thing I want to just share before I close my presentation. In Bihar, while working, we have realized how it actually supports our road assets. The damages which actually happens, a pothole, generally it takes 30 days to 45 days till it actually identifies, and then somebody comes and repairs it. Now, by adopting this digital system, real-time monitoring, the response time has come down to less than 7 days. This is our 3 years of experience. It's all well displayed, and we have central command control system in Bihar, where it has been noted that 7 days. So that means a pothole, if repaired in 5 to 7 days, that ensures that our asset life increases by at least 35 to 40%. And not just that, maintenance cost reduces drastically. 100 rupees cost to maintain a larger pothole. I'd say it will cost 10 rupees to maintain a small pothole. 3 days old or 5 days old potholes. So these are the measurable benefits, and which we have actually experienced, and it can be projected to state authority to take a decision, which is these numbers are actually we have achieved. So please get back to me for any further discussion to know these numbers how we have achieved. Thank you very much, sir. Thank you very much.
Thank you, Mr. Rishish, about the experiences in Bihar. We have the third paper, a technical audit and rating approach in enhancing highway infrastructure by Divya. Divya is a senior engineer with the Cube Highways Technologies Private Limited, where she is actively involved in auditing, evaluation, performance monitoring of NH. With over 4 years of experience, professional experience, she has worked across highway project planning, operations and maintenance audits, payment distress analysis as per IRC 82, IRC 83, safety assessment. She is also a Ministry of Road Transport Highways Hackathon 2024 award winner, contributing to digital transformation in highway infrastructure. Over to you, Divya, now.
Thank you, sir. Thank you everyone for giving us this opportunity. I'm on behalf of Cube Highways Technologies here to present our paper, a technical audit and rating approach in enhancing highway infrastructure. India's highway infrastructure is strengthening its focus on quality, safety, and accountability through structured audit frameworks. With growing emphasis on developing durable and high-performance infrastructure, NHAI and MORTH are promoting digitally enabled audits, shifting from periodic manual inspections to technology-driven monitoring using drones, AI analytics, and integrated platforms. In addition to this, NHAI and MORTH are also promoting digitally enabled audits, shifting from periodic manual inspections. In addition, rating and ranking of these structures are also given by NHAI to foster a competitive environment, and this transition enables continuous, objective, real-time evaluation, improving the transparency and efficiency in highway development and maintenance. Rapid highway expansion and aging infrastructure have made traditional manual inspections inefficient, subject, and difficult to scale, often resulting in inconsistent data and delayed maintenance decisions. Transitioning to integrated digital audit and rating systems improves efficiency, accuracy, and infrastructure performance management. Cube Highways Technologies have implemented a specific department called Technical Audit and Rating to diligently monitor its growing portfolio. This mainly focuses on operation and maintenance and through georeference video collections, AI/ML-powered asset detection, automated image extraction and digital audits, and then issue identification and rectification. The step one is video collection. Having a vast portfolio, we are collecting videos of each asset on a monthly basis on both day and night. And this video collections, through this video collections, the auto-generated random sampling questionnaire is generated on 10% sample basis. And this AI and ML in-house tools are used for video processing and the image extraction. Then a specific evaluation team is deployed to audit the assets and their corresponding parameters. These are the categories and associated divisions which are audited by the technical audit and rating team. For example, in roadways divisions, we are auditing pavement, embankment, shoulder, curb, and drainage. And for road signage and furnitures, we are auditing anti-glaziers, hazard markers, kilometer stones, hectometer stones, solar blinkers, delineators, and so on. In the same way, for 7 associated divisions, which is developed in correspondence to IRC SP 127/2020, a rating module has been developed. This is the sample video capture application and the rating application, which is developed in-house. Utilizing the video, an asset map is generated for each project on a monthly basis, identifying the missed new assets in case of any COS or any damaged assets in case of any damaged assets. Then audit is conducted based on the extracted images. This image extraction is done based on the geo-referenced chainages, and these chainages are generated on a random sample basis for the corresponding project. So on a whole, we are auditing across 25 projects, and the auditing is conducted in 2 methods, digital rating and conventional rating. For example, in case of roadway category, the pavement, curb, and shoulder can be visualized through the digital images. Whereas in case of drainage and embankment, this can't be visualized through the digital images. So as of now, we are asking site team to upload the images of the embankment and drainages of the randomly generated chainages, and then the auditing is verified by the team which is on the HO level. The images are also extracted based on AI and ML from the video captured for the entire asset. Another interesting feature is we do have night images also captured for the functional condition. For example, for signboards, we do have 3 questions such as cleanliness, physical condition, and functional condition. For cleanliness and physical condition, day images are extracted. As far as functional condition concerned, which requires if the signboard is performing to its reflectivity or not, we do ensure that night images of that particular corresponding chainages are also being extracted, and the rating for the same is being given. On a whole, we do give the performance insights through dashboards for corresponding projects on a holistic level. For each month, we do present a holistic dashboard with all the performance parameters, number of questions audited, physical condition ratings, such as we mainly focus on cleanliness, functional, and the physical condition. Like all the questions are subcategorized into that particular parameters, and on a whole, we do let the portfolio know where they are standing on a monthly basis. And the other interesting thing I would like to let you know is we have developed the framework to award the best performing assets in correspondence to the NHAI Excellence Awards. And this was the first year we gave the NHAI Excellence Awards on the CUBE 10 years anniversary. This is the flow chart of the entire process. Initially, we do collect the video of the entire entire asset, for the day and night. And the video, if the requirements are adhered, we do process it with AI and ML, and the automatic images are extracted based on the georeferenced changes. Then an in-house high-rate application tool is being utilized to rate the particular georeferenced image, and then as I said, digital and conventional ratings are vice versa. Like if digital ratings, initially it is given by HO team, and then the SPV team on the site level verifies if the ratings are on a realistic basis or not. In the same way, in the whatever ratings are being provided by the SPVs, we do re-verify it and cross-check it. If we did provide the SPV with a concern button where we did let them know that if they have any concerns with the ratings provided by us, they can press that button, and then we do know that they have an issue with that particular rating, and then we do initiate discussions regarding the same and finalize the ratings. Based on the finalized ratings, we do develop a finalized report for all the projects, and then on a holistic level, we do have a consolidated level report as well. The key advantages of the technology-driven technical audit framework include improved asset condition insights that support data-driven budgeting and maintenance planning. The system also enhances overall infrastructure quality by promoting standardized and consistent maintenance practices. It enables objective and transparent performance evaluation through standardized rating methodologies. The integration of AI, geo-referenced VO surveys, and digital monitoring ensures accurate, scalable, and repeatable audits. Additionally, the framework also provides a comprehensive asset coverage, supports efficient decision-making, and improves long-term reliability and sustainability of highway infrastructure, fostering competitive performance among the ecosystem. I would like to conclude by saying that we have explored the transformative journey by conventional inspections to high-fidelity technology-driven audit ecosystem. By integrating AI-powered data collection and standardized 4-point rating methodologies based on the IRC SP 127/2020, we have efficiently removed subjectivity and replacing it with data consistent reliability. Our framework focuses more than just monitoring. It bridges the gap between precision technology and strategic outcomes. Through actionable visuals like heat maps and trend indicators, we do empower stakeholders to move towards intangible benefits such as optimized resource allocation and prioritized maintenance planning. Ultimately, the digital highway governance ensures that our structure is not just managed for today, but built for long-term sustainability and enhanced network reliability. As we move forward, the digital highway, as said by our chairman, will serve as the backbone for safer, more efficient, and transparent infrastructure management for years to come. Thank you.
Thank you, Divya. We'll discuss that further. The next presentation is on effective role of a non-nuclear density gauge in SMA layer by Mr. Ayush Kumar. Ayush Kumar is working as a senior engineer with the CUBE Highways Technologies. He has actively participated in record-setting achievement of construction of 51,896 metric tons of bituminous mix in 100 hours. He is also successfully laying of approximately 115 kilometers of SMA. I'm sure that Ayush experiences on the use of non-destructive testing in quality monitoring will be helpful. Over to you, Mr. Ayush. You can take about 10 minutes time.
Yeah, before Ayush Kumar takes over, I would like to announce that the poster presenters are requested to be with their posters at 2:30, and jury will go to the posters for evaluation. From 2:30 onwards, please be there after taking your lunch. Thank you.
Thank you, sir, for giving me opportunity to speak over my case study, an effective role of NNDG in SMA layer. slide is not moving. How the Coming over to next slide, there is a flow chart of overview. What is NNDG? Importance of NNDG in SMA layer, objective of the study, instrument and data approach, data collection and analysis, limitations and conclusion, what the results are coming. Go to the next slide on overview. What is stone matrix asphalt and benefits? SMA offers high durability and excellence rating, resistance rating to making it ideal for highways. Limitation of nuclear gauges. Nuclear density gauges have radiation hazards and regulatory issues, posing safety concerns. Advantages of NNDG. Non-nuclear density gauge provides safe, accurate, and real-time compaction monitoring without radiation. Study finding and benefits. Strong correlation of NNDG reading with core density validates its use for quality control and efficiency. Now going over to what is NNDG. A non-nuclear density gauge is an advanced radiation-free field instrument that measures the in-place density of asphalt and other pavement layers using electromagnetic impedance technology, which gives a precision without radiation, instant feedback, cost efficient and sustainable. How to use NNDG? First we do the marking of the base plate, then we take the measurement, then we check the reading, which is showing on the display of NNDG. Importance of NNDG in SMA layer. Stone matrix asphalt is bitumen-rich, gap-graded, highly rut-resistant mix designed to serve heavy load traffic, where mixed compaction is the cornerstone of durability. Achieving the specified in-place density ensure stone-on-stone contact, minimize voids, and prevents premature rutting. The non-nuclear density gauge transforms this process by delivering real-time radiation-free density measurement during compaction. Its importance lies in safety and compliance, precision and speed, cost and sustainability, performance assurance. Safety and compliance eliminate radioactive sources, removing regulatory hurdles and health risk. Precision and speeds provide instant accurate feedback for intelligent rolling decision before the mat cools below the critical temperature. Cost and sustainability reduces destructive core sampling, accelerates quality control, and supports green construction practices. Performance assurance enables uniform compaction across SMA layer, ensuring long-term structural integrity and superior service life. Objective of the study: evaluate the effectiveness of non-nuclear density gauge as a safe practice, validate accuracy and reliability of NNDG by correlating its reading with core density results, analyzing compaction trend across roller passes to identify the optimum rolling effort for achieving target density without overcompaction, demonstrate real-life decision-making benefits for intelligent compaction and quality control, highlight sustainability and cost efficiency by reducing reliance on destructive testing and radiation-based instrument. Now, instrument and data approach. For instrument and data approach, we use pavement quality indicator PQI 380. Measurement principle. Its measurement principle is uses impedance spectroscopy, where a low voltage electric field is transmitted through the asphalt layer. The device measures the electrical impedance, which is influenced by aggregate gradation, asphalt binder type, air voids contain moistures. Since electrical impedance varies predictably with the mixture density, the gauge converts its electrical response into density using calibration curve. Now, general principle across NNDG. Every NNDG works on variation of these electromagnetic properties: dielectric constant, electrical resistivity, impedance. Material properties change systematically with asphalt density, allowing device to compute percentage compaction. Now, why this work technically? As asphalt is compacted, air void reduces, contact between the aggregate increases, conductive path and dielectric behavior changes, electric impedance becomes more stable and predictable. Thus, NNDGs interpret density by analyzing the electrical characteristic rather than radiation absorption. Now, come to the next part, that is calibration requirement. As we know, every machine requires calibration. So for NNDG, calibration is also important part. Because electrical properties differ for every MISC, the NNDG must be calibrated using core densities. The difference between NNDG density and core density is computed. The difference of both the density is called offset. And offset is the offset is applied to make reading match the specific mix. This ensures the accuracy and repeatability for each project.
Are you sure to conclude in another 2-3 minutes?
Okay. It will be, sir. Advantages over nuclear gadget: no radioactivity source, high repeatability due to stable electronics, instant stabilization, radiation stacking errors. The data collection approach: 5 points were selected on facely compacted mat for calibration. NNDG reading were recorded using 5-point cloverleaf pattern at each location. Corresponding cores were extracted and tested in a certified lab using ASTO 166 standard. The average offset was computed and programmed into the NNDG for further reading. Instrument and data approach. This is the process of doing the calibration and taking the measurement in a cloverleaf pattern. We take the reading in the center, then on the all four, then we take the average. And the difference between the core density and the average of this density is called offset, which we feed into the NNDG to match the reading with the cores. Now we can see the strong correlation was found between core result and NNDG with similar trends observed in the compaction. You can see the trend, how the trend is going with core results and NNDG result, which is very similar. Now we can see the correlation coefficient is coming 0.863, which is showing good result. Coefficient of determination is coming 0.744, which is also showing good result, and root mean square is also 0.51% of the density, which shows the results are very satisfying. Now we can see in this slide, we can see that after the 4 pass, we can see we are achieving the required compaction of SMA, that is 94%. And we can avoid the 5th and 6th passes, and we can save the cost from the 6th and 5th pass. And it will be time saving also, and temperature will, within the temperature we can complete our rolling in the SMA. As we know, SMA temperature gets down rapidly.
Are you sure to conclude?
Yes, sir, there's 2 more slides. You can also see the measurement at each passes we have done. So you can show after 3rd pass and the 4th pass, we are getting the desired compaction. And for every point, we have taken 50 readings, and total of 350 readings were taken, and we have got this conclusion of each passes. Now we can see we have done over more than 2,500 readings in the complete project, and we have seen that after 4 passes, we have got the result which is coming between 95.2 to 95.6, and total number of readings were 2,500. And we can see that in this graph at each 0.5 meter offset, how the trend is going and how the result is coming. And every machinery has a limitation. Such it has also limitation over surface. The surface should not have moisture and should not be irregular, and the calibration should be done on time. And also there is a temperature variation also observed. We have if the asphalt is very hot, then there is a unstable reading we have observed. In the asphalt is cooling, then inconsistent reading observed. If asphalt is cool, then we have got the best result and better result. Now we come to the conclusion that NNDG ensures accurate density without radiation hazards, enhances compaction efficiency and quality of the SMA, supports sustainable pavement construction and reduces core cutting and identify fatty spots. Real-time data enables correction, help identify soft spots and inconsistencies, recommended for SMA applications. Thank you, everyone.
Thank you, Ayush. Yeah. The next presentation is on a data-driven road asset management framework, a case study of Odisha by Dr. Pradeep Kumar. Dr. Pradeep Kumar is heading the Payment Evaluation Division at CRRI. He has over 29 years of R&D experience. I think he is currently leading a major road national project on the Odisha Road Asset Management System, covering 22,866 kilometers, and as well as airfield payment management system for over 10 airports in India. I feel that the most knowledgeable person on the asset management is Dr. Pradeep Kumar. Let us hear from Dr. Pradeep about his experiences in the Odisha RMMS. I know very well that he requires more time for the presentation, but because of time limitation, I request Pradeep to conclude in 10 minutes, share the highlights of the Odisha RMMS.
Thank you, Chairman Sir, for the brief introduction about myself. A very good afternoon to all of you present here. As mentioned by the Chairman Sir, I am going to present the ongoing study in the state of Odisha related to the maintenance of 22,866 lane kilometer of road network, which constitute of the state highways, major district roads, and the other district roads. And actually, one paper was submitted to this conference, and I would also like to acknowledge the authors, Dr. Akash Gupta and Professor Manoranjan Parida, the former director of CRI, and the professor from IIT Roorkee, and Dr. N.C. Pal, who is the technical expert from the Works Department, Government of Odisha. As we know, I am talking about the management of the road assets. Mainly, the focus is on the maintenance part of the existing road network. Was given to us from the, I think I should be here like that. This is comfortable? Yeah, because I want to see the screen also. Yeah, so what are the challenges? What challenges normally we face while we are managing? We want to develop something related to the management of the existing road network. So if we see, the current pressure is the rising traffic demand. As you see, the increased volume and the heavier axle loads, they accelerate the deterioration of the roads. So our roads are deteriorating very fast because there is, if you all will agree, there is no much control on the overloading of the traffic on the existing road network. So this is one reason. And we have always the constant budget related to the maintenance part. When we talk about the maintenance, then there is scarcity of the funds. And the legacy practices is the reactive. We are not proactive in nature. When we see some pothole after 1 or 2 months, a pothole is created, then we think about it, whether when to tender it to repair it or like that. So we are not much proactive. When we see the cracks are there on the existing roads, we should be proactive. So these are some challenges. If we go with the traditional approaches, so the reactive fixes, as I mentioned, we are subjective in nature and which are contributing to the high cost, which is not desirable at all. And what I am presenting here with the Odisha state study is the data-driven study. We call it as the RAM, Road Asset Management Framework. The unified data, it provides the first thing is to create the unified data and the HDM4 analysis. Not only HDM4, you can use any PMS tool which is available in the world, but we are using in our country the HDM4 model framework. And then we are doing, we are optimizing the budget. What budget we are optimizing? Basically, we are maximizing the economic benefits. How we are maximizing the economic benefits? We want to minimize the maintenance cost, and also we want to minimize the road user cost. So we have two major parameters. One is the maintenance cost for the network, and the second thing is the road user cost. So we have two parameters, and this is the optimization problem which we are solving using the HDM4 framework. So this is the basic structure. I will not go in more details because the time is very short. If you want to develop the road asset management system, then we need to focus. First thing, we want to know our road network. This is the first basic thing, and how you will collect the information about the inventory and the health of your road network. This is the solution is there. The modern data collection techniques which are very much available. If I talk about before 15 years or 20 years, people used to say the PMS, all PMS or road asset management system is a failure. Nobody is going to use it because at that time, not much technology was not there. Okay, if I've been given a road network of 1,000 kilometers, then how I am going to collect the data, the visual way? So that was not possible. But nowadays, the technology is very much available. The network survey vehicle system give you the road inventory and the payment condition data, falling weight deflectometer for the structural health, and AVCC, vein motion, and the ground penetrating radar. Even you can see inside the payment also. So much more technologies are there now. We are seeing from NTRO, the integrated technology is also there, which can give you the all data in one platform. The second thing is the platform. What platform? The road information system. We want to put all this information at one platform. That is the unified data I am talking about. Normally, at present, we are using the WebGIS-based information portal, which has a dedicated server, cloud storage, digital mapping, thematic query system. All we know about the GIS. So this is a WebGIS system, but now we are thinking more beyond that, the digital twin technology that will also help to visualize the entire road network in the 3D platform. So once your road information system is ready, then you have to link your road information system with some management tool, the PMS tool, where you are going to solve the optimization problem. I have just given you two parameters, the maintenance cost and the road user cost. So this is the platform, the management tool, which will do this for you. It will perform the life cycle cost analysis for you, but still there are some limitations in the current practices in PMS also, but I hope that the next version of the PMS tool will incorporate all those issues also that I am not going to discuss right now here. So one good thing is that IRC has published with the contribution of all the first road asset management guidelines. Now we have the road asset management guidelines also in our country, IRC 130/2020, which we have completely complied in the state of Odisha for the development of the road asset management system. And just now, let us come to the Odisha state study. It has 12 administrative circles, and the road network which was given to us was 22,866 lane kilometers, and the roads were classified as the state highways, MDR and ODR roads. And if you see the traffic condition, it was very heterogeneous network with diverse traffic levels, terrain types, and the pavement structures. So this was the completely, if you see, the state highways were 28%, and 12% MDR roads, and the 60% the ODR roads. This was the network which was given to us, and this was the methodology for development of the annual maintenance plan. The objective was to develop the annual maintenance plan, that is the budget and the strategy for the maintenance. So this was the strategy adopted by us. Sorry. Yeah. So what we have done, first we have conducted the condition survey using the network survey vehicle, and based on the condition survey, we have calculated the PCI, the payment condition index, as per the IRC 82 code. And once the PCI score were available for each and every single road, then what we have done, we have just segregated the roads which were having the PCI score less than 80. Okay. That means we assume that the roads which were having the PCI score more than 80, they are under very good to excellent condition. They need not require much overlay type interventions. And then we have conducted the falling weight deflectometer on the rest of the roads for the structure evaluation to just work out the overlay requirements. And this was and we simultaneously traffic data and Excel load data was provided by the IIT Bhubaneswar. I would like to acknowledge them also here. And then payment details and history data and were collected from the PWD department, and the cost data was collected by the schedule of rates from the Odisha government. And all this information was clubbed to the road information system, which is the Odisha Road Asset Management System, which was implemented by the Works Department, Government of Odisha in the year 2015 itself. It is working very well. And then all this information was linked to the SDM4 module for the optimization and development of the strategy and other things. Now I will just rush, just a minute. This is the code I am talking about for the calculation of the PCI, which is very much available for the information of all. And these are the modern data collection techniques which are very much available now in the country, except for the ski distance, which we are looking for in the future also. So these are the, if you see, what I'm just going to show you in this slide, this is the OREMS portal. OREMS portal you are seeing here. I think this is not visible. Okay. So you are seeing in the right side, the OREMS portal. You are seeing some red color or orange color, green color, and all lines. They are representing the state highways, major district roads, and other district roads. This is the data which was collected by the network survey vehicle system. And you can visualize the data in GIS platform also. And if you see, the OREMS here in Odisha acts as the information backbone. Basically, it is the information backbone for the, and the SDM4 serves as the analytical engine. This is what I want to say. And the framework, if we see, the first we have collected the data, which called the integrated data collection about all road geometry to the traffic volume, Excel load and growth I have mentioned. And then using SDM4, we have done the payment iteration was predicted, future condition, and life cycle cost analysis was performed. These are the various stages or the framework you can say. And finally, once the SDM4 was done, we were landed with some economic indicators for comparing the treatment options, like the net present value, what is the benefit to cost ratio, what is the IRR. And based on that, in the step 3, we have taken the decision based on these economic indicators, and decision were taken. And finally, for each section wise, the maintenance plan, strategy, and budget was performed. So these are the overall outcome of the study. If you see the entire network, 22,866 lane kilometer, we found because the old roads were about 5 to 6 year old, there was no major maintenance was done on this network. If you see, the preventive maintenance was only 1.19%, and routine maintenance was 1.25%, and thick overlays more than 40 to 140 mm was suggested for 23.63% of the road network, and thin structural overlays were on 73.92%. So this was the outcome of the study. And there are some slides which indicates you when you are not doing any maintenance, how your roughness will the progress actually. And if you are doing the appropriate maintenance, then you can save not only you will keep the road network in good condition, but you will save a lot of money also. So these are something. I think time is over, sir. Yeah, that's why. So I am just rushing. So this is something. The overall key benefits I just want to mention: 5 to 10 years, you can extend the life of the payment. 20 to 30% you can reduce the cost. I am not go in detail. And this is the actually we want. Actually, this is not a presentation. Actually, this is the message I want to give to all the states. The benefits of implementing RAMs. So these are the benefits and the process how you will develop the RAMs. The vision is very clear. We need to establish a ecosystem for basically the RAM ecosystem we have to develop, so that we can not only increase the life of the payment, but we can save a lot of money for the nation. Thank you very much.
Thank you, Dr. Pradeep. And the last presentation is on Namibia's road management system, a global best practice case study. We have with us Mr. Ferguson Palse. May I request him to present in about 10 minutes' time.
Thank you, Mr. Chair. Thank you, ladies and gentlemen. It's a great honor for me to be here to be able to share the road management system case study of Namibia. I want to start off by just giving you a brief background of Namibia. Namibia is located in Southwest Africa, just north of South Africa, south of Angola, and west of Botswana. Just to have a feel of where exactly we are located. I know most of us don't know much about Namibia. Quite a small country in terms of population, but I'll get into that now. But in terms of size, it's about the quarter of India, but Namibia only has about 3 million people. And with that said, I think you will then appreciate some of the problems that we have in terms of asset management. We have a vast country, like I just said, a quarter of India's population, but we only have 3 million people. And hence the reason for us to have a robust road asset management system in order for us to make scientific calculations and stick to that. For those of us that would like to see a little bit more of Namibia, I believe we're playing the last T20 World Cup match, warm-up World Cup match tomorrow against India in Bengaluru. With that said, like I said, small population, 3 million people. I don't know what our chances are playing against India that has about 1.3 billion people. Yes, just to get into the asset management, I want to start off with where Namibia's road management started off. In about the years 1995 to 2000, Namibia went through a road section reform. And what then transpired at that particular time was that 3 main entities was born, of which I represent the Roads Authority, the Road Fund Administration, and the Road Contractors Company. And part and parcel of this case study is you're not going to hear anything new than was said before in terms of asset management, but just the way we went about it is to make sure that our processes are legislated and specified, because what we see normally when it comes to doing the right thing at the right time, it's normally about who's got the strongest voice or speaks the loudest or has the greatest influence. And that's what we try to avoid in Namibia. And what you'll see here with this as well is that within the Act of the Roads Authority, the operation of a road management is built in. That's just an indication of some of the highways that we've built. And then the idea behind the whole reform was basically to commercialize, have sustainability, efficiency, and accountability. Commercialize in the sense that roads are assets, and in order to take care of your assets, you need to have a robust, predictable funding tied to it, and that's where the road fund also comes in terms of the road user charges system that allows for the road fund to ring-fence these funds primarily for maintenance strategies. I'm not going to go into the detail of the HDM4. I just want to say that Namibia also has introduced the HDM4 in terms of our analysis. The reason we went with that is the HDM4 is a World Bank model, and it's difficult for anybody to argue against. With that said, we have another model, off-the-shelf model from the CSIR in South Africa, the Struman, which we use as our bridge management system, and then the rest of the systems are developed in-house. And then I just want to go into the role that the road management plays by making sure that the mandate of these entities that was born that I mentioned previously plays. That's just the network of Namibia. We have about 50,000 kilometers of national road. The Roads Authority is responsible only for the national road network. Vast country, 50,000 kilometers of road, and that basically shows you that the cost per kilometer for Namibia is quite high due to the fact that we have such a low population. And then I just wanted to also just illustrate a little bit some of the mandates that we're responsible for. Built in the Act is the minimization of total transportation cost, and that basically is what the Roads Authority is there for. As most institutions have funding restraints, there's nothing different with Namibia. Currently, we're funding our network at about 40% below optimum. But the important thing is that once you receive these funds, can you still prioritize by redistributing and doing the right thing at the right time? And I think that's what it's all about. This is basically just an indication of, I just want to go back to that. This is basically just an indication of what the gentleman spoke about earlier, about doing the right thing at the right time. And we've actually quantified that for every dollar not spent on the road network, the road user incurs an extra or additional cost about 2.9. So for every dollar saved, the road user cost goes up about 2.9. And that's the beauty of the management system, to be able to quantify it, and so decision makers can visually appreciate that. In the interest of time, we basically use the same technology as what was presented earlier in terms of data collection, road surface profilers, falling weight deflectometers, the traffic counting stations, monitoring stations, that equipment that we get from the microsurface provider in South Africa. Nothing new from what is used in India. We have an IREX system as well, and application that we use on phones and tablets as well. The team is currently busy utilizing that application of software as we're speaking, to collect visual data in the field, upload it immediately to a cloud-based system, and that information is readily available. The beauty thereof is just, you can ensure quality, because assessments can't take place when an assessor is not on site, and then obviously real-time information. We can actually monitor them on a map right now as they do the assessments throughout the country.
Also, you have to conclude.
Okay, I can conclude. Okay, just quickly in conclusion, in terms of what I've just said with regards to the Namibian road asset management system, 5 key takeaway lessons and recommendations. Number 1, institutionalize road management throughout legislation to ensure continuity and accountability. Integrate the road management system with funding mechanisms so budgets are driven by evidence and not discretion, who shouts the loudest. Thirdly, balance economic and social roads using preservation strategies to maintain accessibility and safety. And then also invest in people and processes and not just technology, because the management system compromises of software, hardware, and people. Most importantly, the people. And then lastly, use road management system outputs for stakeholder communication, make trade-offs and transparent, and be transparent. So in conclusion, Namibia's road management system demonstrates how data-driven planning when embedded with institutional and legal frameworks, can significantly enhance government's transparency and sustainability in the road sector. The road management system has proven to be more than a technical tool. It is a strategic asset that preserves institutional knowledge, supports informed decision-making, and safeguards public investment. Thank you very much.
Thank you very much, Mr. Palse. I think we had 6 interesting presentations on the digital transformation of highway infrastructure to asset management. So I congratulate all the authors for sharing their knowledge, experiences in the asset management, as well as especially in data collection. I think from what we have heard so far, I don't want to go individual speaker by speaker and what they spoke, because you listen to them. Let me summarize the application of this digital data that we are collecting. So what we learned in the process is that, supposing if a network has to be assessed by the technology, tools, equipment adopted by Dr. Ghosh, or by Mr. Rishish, or by Dr. Pradeep, or by anyone else, will the data be uniform? Will we get the same numbers? How do we make use of the data? So data becomes the backbone. So what is needed at this point of time is standardization of the data collection format as well as reporting. That is more important. Otherwise, every agency will report in their own form, and we collect the data using different equipment. We will not be able to compare. This again warrants calibration of the equipment, normalization or harmonization of the data collected by the different equipment. Only then we can apply these numbers for decision making. More importantly, the performance depends upon the age and construction quality. So the application of this data, somewhere we have to consider what is the age of the pavement, what is the construction quality, so that we will be able to predict the performance of this pavement for decision making. Even when you want to take a decision making, it can be a preventive maintenance, it can be corrective maintenance. Again, for asset management, we should know what is the appropriate type of preventive maintenance. It can be a fog seal, it can be slurry seal, it can be microsurfacing, it can be thin overlay. Similarly, thick overlay, again, can be different options. It can be DBM, BC, SMA, with polymer, without polymer. So there are several options. So this asset management, when I want to have the lowest life cycle cost, I am more interested to know how this asset is going to perform, so that the maintenance strategy that I adopt will result in the lowest life cycle. Now there are added dimension in terms of sustainability. Can we talk about sustainable materials? If I use a sustainable material, will it perform like time-tested material? Is again a big $1 million question. So the effectiveness of the treatment is again needs to be quantified. Cost economics come into picture. Life cycle assessment comes into picture. So we have several challenges apart from the data collection. So let us start normalizing the data collection process, standardizing the procedure first. Then we can apply this data in asset management. I think we had a long way to go. Even though we say that we have done so many asset management, I still has to look beyond data collection to the application of the data in asset management. So I thank you very much for your patience listening, and we look forward to interact further with those speakers and among ourselves, so that India can have a better road asset management in the years to come. Thank you very much for the opportunity.
Thank you. Thank you, Professor Veera Raghavan, for summing up all the presentations that have happened. Please give a round of applause to all our speakers on stage. We want to thank them for sharing their knowledge with the audience. I request the session chair to please present mementos to all those who have presented the papers here. So I request you to please present a memento to Mr. Rishi Jha first. I request the session chair to present a memento to Indrajit Ghosh. A memento for B. Divya. I request you to present a memento to Mr. Ayush Kumar. A memento to Mr. Pradeep Kumar. And a memento for Mr. Ferguson Polsey. I request Professor Manoranjan Paratha to please come up on stage, and I request him to please present a memento to Professor A. Veeraraghavan, our session chair. I request all of you to please gather for a group photograph as well. Thank you all for your presence here. We will be slipping into our long lunch break. I request all of you to use this opportunity to visit the expo areas. We have one expo area which is right outside this hall. You can take the exit and visit the expo area. There is another expo area for which you have to walk towards your left side, and beyond the room where food is being served, we have an expo area there as well. So I request all of you to please visit the expo, because at the expo you will find the latest offerings, products and services of all those servicing the needs of the road infrastructure industry. Please do join us for lunch, which is being served in the same hall where tea and coffee were served, and please use this time to catch up with your friends and visit the expo as well. We shall now begin with our technical session 3, and the topic for this session is data-driven approach to road safety for forgiving roads. India's very high rate of road fatalities makes data-driven road safety not just useful but essential, especially for building forgiving roads where inevitable human errors do not result in death or serious injury. The core idea is to move from reactive fixes to evidence-based systematic prevention. Black spot identification using crash analytics, speed and risk mapping through traffic data, and life cycle-based asset management are some of the methods being adopted to improve road safety. For this session, please welcome on stage our session chair, Mr. Tony Matthew, Head Operations, TRL Technologies. Please give a round of applause and welcome Mr. Tony Matthew on stage. He has more than 20 years of experience with road transport sector and has implemented road asset and safety management systems for clients across countries in Europe, Africa, and Asia. He is responsible for operations at TRL Technologies and also oversees the delivery of TRL software projects in Asia and Africa. Please welcome our speakers for this session. Please welcome A. Ramya Devi. She will be giving a presentation on PPP-driven innovation in road user safety. Please give a round of applause and welcome A. Ramya Devi on stage. Please welcome S. Padma, who will be giving a presentation on accident data analysis with economic evaluation of countermeasures. The next presentation will be presented by Monali Bose. So please give a round of applause and welcome Monali Bose on stage. She'll be talking about AI-driven crash prediction models for heritage city road networks. And please welcome on stage Sharad Sharma, who will give us a presentation on shadow cum material vehicle innovations for enhancing prevailing work zone safety practices. Please give a round of applause to our speakers on stage. Again, I request all speakers to please keep their presentations to 10 minutes, and I will hand it over to our session chair to take this session forward. No gun mics? You require a gun mic?
Yes, please come in here. Yes, you are in, Mr. Pawar. So I think, yes. Please join.
We also have Mr. Satbir Singh Pawar, who will be talking to us about safety evaluation by use of surrogate safety parameters on 4-lane interurban roads in India.
Okay, thank you. So we were supposed to start this at 4:50 and end by 6:15. Yeah, so you can imagine we are now on 10 to 6. Yeah. So we have interesting 5 presentations on road safety, different aspects of road safety, from public-private partnership, innovation, surrogate safety measures, countermeasures using IMAP, AI-driven crash prediction, and works on safety. Okay, I welcome all the speakers. Our first presentation is on PPP-driven innovation road user safety by Ms. Ramya Devi. Ramya Devi is an assistant engineer with Tamil Nadu Highways Department and has extensively worked on externally funded projects. So, yeah, please carry on. Just want to, because we have a paucity of time, to a request to all speakers to conclude your presentation within 10 minutes. Yeah, I know it's a skill, but I'm sure you all have that skills to deliver the presentation in short time. There's a risk also when you have a last session. Yeah, right. Over to you.
Good evening. We are all gathered with a shared mission to develop Vision Zero India, integrating safety, sustainability, and technology in infrastructure. Adhering to this vision, our team, Hemalata, Divisional Engineer, Anand Muthusamy, Assistant Chief Engineer, and myself from Tamil Nadu Highways Department, are here to discuss PPP-driven innovation in road user safety, transitioning from fatal road to forgiving roads through empathy-driven design-built road safety under hybrid annuity model. Our roads are not just infrastructure. They carry lives, families, dreams. I quote one Tirukural, Enni tuniha karumam, tunindan ennuvam enbadu ilukku. This means think thoroughly before you act. To think after acting is a mistake. This timeless wisdom perfectly reflects modern road safety. Prevention must come before accidents. Safety must come before speed. Design must come before regret. Our goal is simple and impactful: to design roads that prevent harm, not react to it. Road safety. Road safety is not just about traffic rules. Every accident is not fate. True discipline of the road reflects respect for life and responsibility to society. Road safety means saving lives before accident happen. Road safety is a global crisis. 1.19 million die every year globally. World Bank report says with just 1% of world vehicles, India accounts of 11% of global deaths, and India continues to top road accidents, fatalities, with over 1.72 lakh deaths every year. By this time, when we are proceeding with the next slide, someone, somewhere is dying in road crashes. It is evident from World Bank report, India suffers around 3 to 7% of GDP loss. World Bank also cites many factors for fatalities. Anyhow, vulnerable road users are the highest victims. Experts urges investment in engineering, enforcement, emergency, and public education. That is the 4 E's. World Bank assisted India's road safety program with a loan of $2 million. Let's confine to the ministry's report. 60% of fatal victims are between 18 to 45 years. These national highways and state highways doesn't look like roads. They look like killing grounds. This slide shows growing trends in fatalities over 2019 to 2023. Moth report classifies the major accidents under human error and road environment. Under traffic violation, overspeeding tops. Pathetically, the person with the driving license are the highest in accidents. Most of the accidents occurs in open areas and in straight roads. Accidents are minimum at traffic controlled areas, where falls maximum in the category others as per the report. In India, most of the days are sunny and clear. This dominates the accident occurrences. Between 1 to 10 years, age of vehicles making more accidents. Normally loaded vehicle accidents are highest compared to overloaded, hanging empty and not known. Road accidents by type of collisions of hit from back, head-on collisions, etc. Another human error is non-use of helmets and non-use of seat belts. Rural fatal accidents stops with 69% than urban accidents 39%. Every month, nearly 15,000 fatalities occurs in India, where highest in the time between 3 p.m. to 9 p.m. After collection and analysis of these many data, MORTH has suggested mitigation measures under 4E strategy to reduce the accidents by 50% by 2030, a sustainable development goal. News Daily also acknowledges EDAR plays a vital role in data collection. Government has taken many steps under 4E strategy, as rectifying black spots, hotspots, junction improvements, etc. Enforcement through stricter laws, rules, regulations. Cashless treatments to road accident victims under emergency care. Education awareness to public. India not only raising to top in population, economy, military power and technology, also tops in road accidental deaths. India often finds near the bottom rank in human development and society and environmental sustainability, showing how growth outpaced well-being. Where we stand in overall deaths, a data from sample registration system says an unintentional injuries motor vehicle accidents accounts 2.9% in total, male with 4.1% and 1.2% female. In total, these accidents, injuries are not top 10 causes of deaths in India. However, stands the 11th place. Rural areas accounts 3%, not urban, under the top 10 category. Northern region accounts 3.4%, Central region accounts 3.8%, Western region accounts 2.7%. Eastern, Northeastern and Southern regions not accounts in top 10 causes of deaths in India. However, India cannot call accidents minor when thousands of preventable deaths quietly add up to the national warning sign. Government has also allocated rupees 3.1 lakh crores in budget 2026-27 for the infrastructure development. These photographs are our road, Indian roads, self-explanatory about our road environment, and human error is inevitable. Can you see the pictures? This is all taken up from the internet and social medias, now trending in social medias. The real danger is we have started accepting this chores as normal. Supreme Court directs Supreme Court directs states, union territories to frame road safety rules before March 2026 to improve roads and pedestrian safety across India, like strict helmet enforcement, safer road design, monitoring, pedestrian first approach, headlights, stops, hooters, focus on hotspots, legal accountability, and grievance redressal. Despite significant efforts by government, NGOs, fatalities remains high. rupees 3.1 lakh crore investment, multiple initiatives. Why do crashes persist? Are our roads consistently safe for all users? Are mistakes and violations inevitable in road? If human error is inevitable, how can system reduce harm? Are our...
Mrs. Ramya, you have 2 more minutes.
Yes, sir. Are our road designed to tolerate mistakes and discourage violations? If government and NGOs policies exist, why did even Supreme Court issue directions on road safety? Have engineering, enforcement, education, and emergency or initiatives from 2019 to 2025 translated into sustained fatality reduction? The picture shows it drastically increasing every year. Why do pedestrians, cyclists, children, two-wheelers remain the most vulnerable road users? How long can we blame overspeeding, no helmets, no seat belts, drunken drive, etc.? What holds us back from zero fatalities? That is fragmented governance with no single accountable authority. Road designed for traffic flow, not survival, not for human survival. Unsafe operating speeds, weak speed management, two-wheeler dominance, vulnerable road users, reactive approach instead of proactive safety, weak enforcement and manpower dependency, poor emergency response and trauma care, underfunding of road safety, weak accountability in PPP and highway contracts, poor data system and crash analytics, political and institutional inertia, urban and rural infrastructure inequality, cultural and behavioral challenges, finally, lack of empathy-driven road design, that is, roads assume perfect driver behavior, no design tolerance for fatigue, distraction, or error, limited adoption of Vision Zero and safety system. What is empathy? Empathy in road safety means designing, managing, and enforcing roads by putting ourselves in a place of real road users, especially the most vulnerable, and building systems that protect. I put it in myself. If a child, elderly person, physically challenged person, pedestrian, cyclist, or tired drivers, would this road feel safe? The goal is not only to prevent violations and mistakes, but to build systems that protect people when mistakes happen. Empathy framework in PPP involves policy, enforcement, and education. Policy should be designed for human limits. Enforcement should be corrective and not punitive. Education, behavior through understanding. Vulnerable road user empathy model concerns exposure, perception, response time, consequences. One more thing.
Can you please wrap up?
Yes,
It's
sir.
time. Yeah.
Sure. The least protected users by the highest price for small errors. Empathy is no more optional. It should be incorporated in our institutional systems. It must be embedded in contracts, audits, and key performance indicators, built in PPP road projects, linked to financial incentives, penalties, and safety performance. Road safety improves not when users behave perfectly, but when systems protect users when they don't. This achieves by minimal pedestrian waiting time, adequate night visibility, and fatigueness for drivers, two-wheelers considerations, school zone empathy, that is encircling the school zone safety, dignified passengers, public transport passengers by adopting good bus stops, rain weather empathy, elderly empathy, forgiveness empathy in design, post-crash empathy. Okay, finally, to operationalize empathy in road safety, we propose a PPP model. I repeat, road users are human and will make mistakes. Road safety system must anticipate human error and reduce its consequences. Empathy shall be embedded as a measurable performance obligation under this contract. This is our structure of the DBRS hybrid annuity model. The same, whatever the contract we are using, design and construction, operation and maintenance. The only difference is we are connecting this with the safety outcomes with fatality and injury reduction. The primary objective of the proposed model is that to transforming a single E approach to the 6E approach.
Okay, can you please, because others have to speak as
with a single nodal agency. The scope of the model covers all the 6C strategies. This is the key performance indicators. Vulnerable protection, pedestrian delay and comfort, nighttime, fatigue and long two-wheeler safety, school and sensitive zone, forgiving roads, post-crash response. This is the KPI scoring and payment linkage. This is the important in our proposed model. We are connecting key performance indicators for the roads for the safety parameters and thereby linking the payment. This is the illustration we have.
Okay.
And we have framed empathy audit and empathy test. So our system, safety becomes the primary contract objective, creates a single accountable safety authority, enforces forgiving, and financial incentives and penalties for the safety performance. This PPP model is new because it is legally transforms private road developers into a life-saving system operators where financial success is achieved on reducing deaths, not by just building roads. This is the roadmap. To achieve sustainable development goals. Do we stop here? Is this a conclusion? I request this forum to take it further. Let's achieve all the visions. Thank you.
Okay. Thank you, Mrs. Ramya, for covering comprehensively the statistics and asking lots of questions, focusing on empathy, which is quite different every day. Thank you. Our next presentation is on safety evaluation by use of surrogate safety parameters on a 4-lane and interurban road in India by Dr. Sadbir Singh Poa. Mr. Sadbir Singh Poa is a civil engineer. He is currently working as Director Technical in Gawa Construction Limited. After his superannuation from Haryana PWD. Over to you, Mr. Poa.
Thank you, Tony. Very good evening, all the dignitaries on the dais and off the dais. The topic of my presentation is safety evaluation by use of surrogate safety parameters on a 4-lane interurban road in India. Road safety is a matter of concern because more than 1,80,000 people are dying on roads and more than 5 lakhs accidents are occurring on the roads, on Indian roads. This is as per government data. I have collected the FIRs of my study area for the last 18 years, in which I have collected FIRs from the police stations because this road falls under 3 police stations. I have compared that accident data of the police data with the concessionaire, and it is found that only 50% accidents are recorded in case of police reports. Actual accidents in India is more than 10 lakhs, and fatalities are more than 3 lakhs. I can say it based on my data. The road safety is a matter of great concern. In spite of lot of efforts, the accidents are not reducing in India. The conventional method for road safety evaluation is by use of historical crash data. But it is a faulty system. It takes lots of time. For analysis of road safety, sufficient data is required, and that will take time. You have to you construct a road, and you observe it for 3-4 years, you collect data, and then you will apply countermeasures for reducing the accidents, but it is faulty. In our case, we have developed a methodology for carrying out a road safety evaluation by use of surrogate parameters. Surrogate parameters, surrogate word meaning is alternative, substitute. This is different method from the conventional one. In case of a conventional safety evaluation, the crash, the accident is a indicator which shows the degree of safety of that road. But in case of surrogate parameters, the conflict is taken as the surrogate measure. There are number of surrogate parameters in literature. These are about 38 parameters, but we have used about 5 road safety parameters in this study. This is conflict diagram. You can see in it, this is TTC, PET, deceleration rate, maximum speed, and variation speed. This is hidden parameter. You can say at the bottom of the pyramid, there are a number of traffic events. As we go on near the head, the severity of the incidents go on increasing. This is study area. Gurgaon to Faridabad, this is 24-kilometer road, starting from Gurgaon and ending at Faridabad. I have collected the data from these police stations and from concessionaire also, and have compared that data. This is a 4-lane road and a toll facility. Micro simulation. We have used 2 software in evaluation of safety. One is VSIM and other is SSAM. In VSIM, we have carried out micro simulation and have developed trajectory files, which are further analyzed in SSAM. SSAM has derived the surrogate safety parameters and their values. In VSIM, first of all, the network is drawn and input data is given. Volume of the traffic, spot speeds, deceleration rate, and all geometrical parameters are given in case of this setting of network. Next is calibration and validation. First, we carry out the VSIM. We run the VSIM for 2 hours, 1 hour for its calibration, and next for driving trajectory files. When the ground data is matching with the drive data from the simulation, it is calibrated. And this validation is done by GS formula, which is a simple chi-square formula. Surrogate safety assessment model is a model. It is a computerized model in which trajectory files are analyzed by microscopic simulation and calculates surrogate safety parameters. This approach eliminates the subjectivity associated with the conventional TCT and allows assessment of safety before crash. Analysis of road safety on intersections. We have collected data, that is volume on all the intersections. In our study area, there are 7 major intersections, out of which 5 intersections were signalized and 2 intersections were unsignalized. Traffic light was provided on 5 numbers and the traffic light was not given on 2 numbers. The traffic volume was collected, spot speeds were collected, geometric parameters were collected. These were given, input was given in VSIM, and trajectory files were derived, and those were analyzed in SSAM. This is analysis of safety intersection by TTC. TTC is time to collision. When 2 vehicles are traveling, this is the time that 2 vehicles take time to collide if they follow their own original path. We have derived the TCT values from our SSAM, and this graph is drawn between reciprocal TTC is taken because severity increases as TTC decreases. It is reciprocal of the severity. That's why we have taken reverse value, inverse value, and probability density mathematical and statistical calibration was taken, and these values were collaborated. This is PET distribution, analysis of road safety on intersection by PET. In this case, post-encroachment time and frequency curves are drawn, and values are found. The mean value is found 1.71 in case of signalized intersection, 1.171 seconds. And the standard deviation is 1.6067 15th PET is 0.10 and 85th is 1.10 and the 95th value is 3.40 seconds. Analysis of road safety on intersection by maximum delta. This is the speed variation of between two vehicles. So this curve is drawn between the frequency and the maximum delta V. And number of conflicts is 19,702. Mean delta value was 4.58 seconds. Standard deviation 3.1. 15th percentile value is 1.7 and 85th is 7.85.
Dr. Paul, 2 more minutes, please.
Sir. This is analysis of severity score by maximum S versus TTC and severity zone based on TTC intersections. As per hydrogen philosophy, these severity zones were derived on the basis of TTC values, time to collision, and maximum S. This is assigned severity score based on TTC and maximum delta intersections. Results. After evaluation, the critical TTC intersection signalized and unsignalized intersection catering to heterogeneous traffic condition is 1.5 seconds and 1.3 seconds respectively. The critical deceleration rate is observed as 0.486 meters per second square, which implies that any conflict with more than this value will lead to fatal crashes. In the same way, the maximum delta V values are reduced. The study corridor on inter-urban catering to heterogeneous traffic movement is 4.58 meters per second. The threshold value of PET of unlicensed intersection is found to be 1.71 seconds. We have compared the accident data of 5 years from 2021 to 2025. And this is the plotted graph in which the location of the intersection according to their severity is given. In case of I-6, the fatality is 1 fatality, 7 grievous, therefore it falls under zone 5. And intersection number 1 have 2 fatalities and 4 grievous, therefore it falls near the boundary of zone 5. In case of intersection I3, I7, I5 and I4, the accidents are 1 fatal. In case of I4, there are 4 grievous, and in case of I5, this is slightly different from the findings. And in case of I2, there is no crash at that location, therefore it falls under I2, falls under zone 1, less severe.
Please wrap up.
The results are very promising, and these are in accordance to ground results. Therefore, the model has given very promising results, and I request the authorities, as the road safety audit is carried out on the basis of engineering parameters only, but for the fatalities, road is also responsible, vehicle is also responsible, environment is also responsible. In this study, in this model, all these parameters has been considered, and these are better indicator of the road safety. Therefore, these studies should be implemented on all the NHI works which are being executed on EPC, hybrid annuity mode or VOT mode. In contract agreement, it is a provision to engage a safety auditor who carries this safety evaluation on the basis of engineering parameter only. NHI should adopt a model, should adopt these models, and a nodal agency like CRRI, IIT Bombay or IIT Roorkee may be appointed as nodal agency who can monitor these road safety audits, and we can reduce the accidents by this methodology. This is all. Thank you very much.
Thank you. Thank you, Dr. Paul. Thank you for presenting that corridor analysis. I hope Gurgaon and Faridabad authorities will listen to that and implement. Our next presentation is on accident data analysis with economic evaluation of countermeasures using IMAP and accident modification factors by Dr. Padma. Padma works as a senior principal scientist in CRRI. Padma had a doctoral studies from University of Leeds, UK, under Commonwealth Scholarship, and is predominantly involved in CRRI on road safety projects across the country. Over to you, Padma. You have 10 minutes.
Okay, good evening, everybody. It's a privilege and an honor to be on this dais addressing the audience. So far we have seen presentations on empathy, of how empathy can drive road safety. We have seen surrogate safety measures. So this is on a reactive approach. So this is totally based on data analysis. And sometimes you have to show numbers for the policymakers to understand that there is a need for an intervention at a particular place. So sometimes empathy doesn't work. So in order to actually give quantified, quantification of where exactly what interventions are needed, we have used a reactive approach. We have used economic evaluation, and we have used accident modification factors as well as safety performance functions in order to go about our analysis. So this is a study which was carried out by a master student from NIT Trichy. So I would like to name the co-authors of this paper. So it was Ms. Arohi Malviya. She was the MTech student from NIT Trichy. Professor Moses Santakumar, he is a professor in NIT Trichy. And Mr. Natraju, he was a former senior principal scientist in CRRI, and currently he is working in Lee Associates. So the topic of my presentation today is on accident data analysis with economic evaluation of suggested countermeasures using IMAP, which is a software developed by TRL UK, and for which Mr. Tony here, who is the chairperson of today's session, is coincidentally the proprietor. And we have used accident modification factors which are currently not available in Indian context, so we have borrowed it from the international studies. So I needn't impress upon that WHO highlights that accidents are, the 8th leading cause of death, and it is one of the major or prevalent causes of death for, younger generation. So I wouldn't reintroduce the entire accident profile, but I would like to here concentrate on what we had done. So as I said initially itself, that we had used IMAP for preliminary analysis or preliminary evaluation of the data we had collected. And we had gone about to do an economic evaluation of the countermeasures we are proposing for the identified black spots. Now, in order to do that, we had actually developed a safety performance function based on the geometric features of that particular area in order to evaluate whether our countermeasures are actually going to be effective or not. So in order to do the economic evaluation, of course, we need to have a prior understanding of accident modification factors. So accident modification, okay, sorry, I forgot, I was changing it here, sorry. So, yeah, so I'm in this slide. So here, accident modification factors is a prerequisite for any economic evaluation. So why it is a prerequisite is because you have to understand how an accident gets reduced once you introduce a countermeasure. So that proportion of reduction comes up from your accident modification factors. So currently, they are not there in Indian context. So for Indian studies, there has not been any evaluation on if you propose a crash barrier, how much would be the reduction on head-on collision, or how much would be a reduction in side, runoff collision. So that percentage is not available. So we had borrowed the accident modification factor from already established studies. So the objective of the study was, of course, to locate hotspots along the corridor and do risk evaluation and analysis. The preliminary analysis was done using IMAP software. And then we had proposed countermeasures as per IRC SP 88, which is the Road Safety Audit Manual. And then we had performed the economic evaluation, and we had developed the safety performance function for the study corridor. So there were 2 study corridors which were chosen. One was SH37, which is a corridor in Uttar Pradesh connecting Bareilly and Kicha. And then SH10, which is Sambalpur, Odisha, connecting Sambalpur and Gorakhpur. So I wouldn't go into in depth on literature review. The crux is that in order to identify, in order to give countermeasures, you have to come up with the black spot analysis. So in order for doing the black spot analysis, there are several literature available on what kind of methods you can apply. The simplest form of black spot identification is, of course, what is given in MORTH, which says that if you have more than 5 crashes happening, 5 fatalities happening in a particular 500-meter stretch, then you are classifying it as a black spot. Or if there are 10 crashes happening over a period of 3 years, then you are classifying it as a black spot. So this is the simplest form. But apart from that, there are several complicated models or several well-established models which actually help you to identify the location. So the 500 homogeneous stretch identification is done through several advanced methods as well.
Different slide.
Yeah. So several advanced methods as well. So after identifying the black spots, of course, we have to do economic evaluation. Now to carry out economic evaluation also, we have several established methods. One is the benefit cost ratio, then we have net present value, then internal rate of returns method. So the effectiveness of countermeasures also is very well established in literature. So in this current presentation, I will touch upon only 2 economic evaluation methods, which is benefit cost and internal rate of return. So SPF, that is a safety performance function, as I said earlier, we have to know whether whatever countermeasures we are giving are actually conducive for that area or for that region, and whether those countermeasures will actually be applicable through similar homogeneous stretches. For that, a safety performance function was also done. So this is a schematic sketch of the methodology which we had adopted. So this is what I had earlier told also, that initially the SH data which we had got was in form of FIR data. So we had to code it into IMAP. So IMAP has an extensive, I think, 3 segment coding platform within which you have to actually extract the variables. So the extraction process in itself is a very tedious one. So from the FIR data, in order to have it into a software-based system, it took quite some process. So that was the initial screening process which we had to do in IMAP in order to find out the clusters. So initial preliminary clustering was done in IMAP. So based on those methodology, we had arrived at the countermeasures and we had done the economic evaluation. Now, if you look at the study corridor, here I have shown you the Google pictures of the study corridor. In MORTH specifications, this is quite an old data of MORTH, since the study, the data was for 2016 to 2019, and the study was carried out around 2022. So 2022, so we had actually, used MORTH data, which was old, that is 2022's MORTH data, in order to identify where the Uttar Pradesh as well as Odisha feature in the list of ranks in terms of road accident. So if you see, it stands 3rd, UP stands 3rd, and Odisha was 12th. And both the study stretches had dual carriageway road with clear width of 7 meters and divided by a median of 3 meters. The data which we had for UP was for 56 kilometers, and the accident data was for between the year 2016 to 2019, whereas for Odisha, we had the data for 167 kilometers. However, we did not digitize the entirety of the data because the process of converting FIR data into a software-based data in itself is a very long process. So the data for SH Odisha was from the year 2018 to 2020. So this is the IMAP preliminary analysis. So here you can see the heat maps, which actually tell you where exactly the accident spots are prevalent. So this is also based on the spatial analysis, which actually tells you where exactly the cluster of accidents are happening. So that's the preliminary analysis using IMAP. This is the distribution of accidents which was found both in SH37 UP and also SH10 Odisha. So here you can see that, the profile of accidents is such that it is increasing over a period of years, and the proportion of fatal accidents is also quite, prominent, making it a good candidate data for analysis. So, as I told you, in the preliminary analysis, we identified the clusters. So the clusters for both SH and SH37 and SH10 were identified. And based on the cluster analysis, we actually define the black spots. In order to prioritize which black spots have to be taken up for first hand, we did an accident severity based indexing. So these are all conventional methods which are followed everywhere. So this is done for both SH37 as well as SH10. And then we have proposed countermeasures. So here in this slide, I am only showing you some countermeasures which we had come up. For SH37, there were several for each of the black based on the nature of accident as well as the speed profile and the traffic profile which was available on that particular road stretch. After identifying the countermeasures, we had done the economic evaluation of each of the countermeasures. So as I said, I am presenting here only two economic evaluation methods. One is your benefit cost ratio and the internal rate of return. So only these two values I am presenting in this particular session. If you see here, based for this SH37 UP, which I have highlighted here in this particular slide, the cost effectiveness of each of the countermeasures, be it short term, medium term, or long term, was evaluated, and we concluded whether they were cost effective or not. So in case of black spot 1, we could see that short term and medium term countermeasures were effective, they were cost effective, whereas in case of black spot 2, only the short term was found to be cost effective, medium term and long term were not found to be cost effective. In case of black spot 3, we had both short term and medium term being cost effective. So similar analysis was done for the other SH as well, but I'm not showing it here. Next, we have developed, as I said, safety
Dr. Padma,
performance.
can you please wrap up? It's time.
Yeah. So as I said earlier, we had also developed a safety performance function. So this is actually an essential parameter in order to assess how exactly our data set is, performing, whether it performs under the conventional dictum of, data analysis as is done in conventional forms of identifying black spots or not. So for that, we had developed a safety performance function using the data of SH37 and SH10. And the results were very promising. And this is a conventional regression model, which is a negative binomial regression model. And this is conventionally followed and established worldwide. So the results have shown that, even though there was the period of data collection is falls during the COVID times, there was not a drastic reduction in number of fatalities. And the study area between the month of May and July were having severe accident recorded. So the accident analysis and the countermeasures were also given in conducive to the nature of the accidents which were present in that particular spot. However, the takeaway is that from the entire presentation, the takeaway is that sometimes in order to convince the policymakers, as I said earlier from the beginning of the presentation, that in order to convince the policymakers, sometimes we need to have black and white numbers. So this is a very set format in order to convince the policymakers that, it is good to invest in these countermeasures. So this is all from my side. Thank you so much.
Thank you, Dr. Padma. Thanks for taking us through the entire analysis. I wish you had more time. I agree that you need evidence to convince policymakers to take action. Our next presentation is on AI-driven crash prediction models for Heritage City Road Network by Monali Bose. Monali Bose is a research scholar at CRRI. She has around 15 years experience in road safety audits in Africa and South Asia, so significant experience. Over to you, Ms. Manali.
Good evening, everyone, Honorable Chair, respected panel members, dignitaries, and my dear colleagues. The theme of the summit is Vision Zero India, that calls on us to move beyond the conventional safety approaches and commit to a future where no loss of life is acceptable. India has made a significant progress in improving the road safety, both reactive and proactive. And we have developed a lot of crash prediction models, like in the last presentation ma'am presented. We have a safety performance function for urban roads. Now, our study, I am Monali Bose, and I'm working under the supervision of Dr. Ravi Shekhar sir and Velmurugan sir, and also under the guidance of Parida sir. So we were working on a comprehensive mobility plan, where we identified that there are different types of roads where already crash prediction model has been developed. Now the road type, we have worked for 2 cities. Now in Udaipur, which we know that it is a famous heritage city, is the road network same what it is the road network in Bharatpur? The urban network and the heritage road network, are they same? Now what is the difference? First let me explain the difference between a modern urban road and a heritage road. A modern urban road, we know, so we have a time constraint, so I'm going to start with the need of the study. Now let me first explain what is heritage road network, what I mean by heritage road network and modern road network. Modern road network is those networks which are planned, which have been planned and designed and constructed as per the IRC code, which are planned and designed for the 4-wheelers, 2-wheelers, all the kind of vehicles as well as pedestrians. But in heritage road network, we often find that the modern road abruptly goes and ends and connects to an unplanned road, where their roads are not planned, they are very narrow, they don't have a proper visibility. So how the crashes behave? What are the variables that basically governs the crash prediction model in both kind of roads? So my study is that this heritage road, basically how fundamentally they differ in the traffic composition, road geometry, pedestrian dominance, and land use intensity. So my objective is that to evaluate that the predictive safety performance function for the urban road, when it is transferred to a heritage road network, will it perform the same way, this crash prediction model? And then I will identify the heritage specific crash generating mechanisms, like what is influencing a heritage road network. Is it the same that the urban road network crashes govern? And third is to establish the need for the context-aware AI-driven prediction model tailored to heritage city road network. So these are the 2 cities with 2 urban contexts. Now one photo is the Bharatpur and this is the city of Udaipur. You can see the difference, that how these roads are behaving differently. Udaipur city, we know this is a very interesting tourist place, and they have many narrow roads which are connected to a urban arterial road, which are a 4-lane road, and then it is connecting to the City Palace road, to the Lake Pichola road, where it is suddenly narrowing down, but their vehicles are also moving, and it is mostly pedestrian dominant. So we can see, if we see the present aspect, how Bharatpur and Udaipur road network, basically they are different. Road width of Bharatpur is mostly wide and it is uniform. Even the 4-lane road are, when connecting to a 2-lane road or a collector road or a sub-arterial road, they are still designed a planned road for the vehicles and for the pedestrians. So there you can find a divided road over there. But in Udaipur, it is mixed. A wide road and suddenly it is ending up to a very narrow road. Then is the geometry, it is planned. And in Udaipur, the planned road is suddenly moving to a constrained road. Then the traffic. In the traffic mix in Bharatpur, it has got segregated, but in Udaipur, it is highly mixed. They have got different kind of vehicles, motorized, non-motorized, mostly non-motorized, and also pedestrians. So parking also, Bharatpur has many formal parking area, but in Udaipur there is very few. They do have, but mostly there is no formal parking. All are informally parking because it is not planned. And then the need. The vehicle-dominated road network requirement is there in Bharatpur, but in Udaipur, it is more requirement of the tourists to walk through the heritage city, to the palace, to the lakes. So it is more required a pedestrian-dominated road. Then the modern road heritage, this modern road to heritage transitions. In Bharatpur, it is very limited. But in Udaipur, it is very strong. There are many places, mostly people come to Udaipur to visit the place. And this space, shared space behavior, it is very limited in Bharatpur, but in Udaipur, it is extensively required because most of the places are still unplanned. This is the crash trend in Udaipur city. If you see the trend from January to December, we have compared the crash of 5 years with the tourist inflows. So if you can see that December to February, the tourist inflow is also very high and also the crash trend. And even in June, the crash trend is high, though the tourist inflow is very low. From the local, we have verified that and we have discussed why this trend is coming. So according to them, that tourists are less, but due to heat and due to the non-functioning of the vehicles or tire breakage or tiredness, too hot situation, often vehicle damages and fatalities occur. Another crash trend, if you can see that there are 80% of the collision type are rear end, head-on and side impact. So what is happening when suddenly a narrow, unplanned road is there, then the vehicles, they cannot have the visibility, or sometimes due to an unplanned gradient of the road network, vehicles are slipping off, moving out. Often they are overloaded with tourists and they are causing crashes. So about all this, apart from all this, rear end and head-on collisions are due to another thing, due to very narrow road, and suddenly a 4-lane road is connecting to a narrow hill road maybe. So there the visibility is reducing and the head-on crashes are occurring.
Ms. Monali, can you please wrap up in a minute?
Yeah. There is, and here also it is found that a heritage safety paradox. A paradox has been observed that though the average severity index is very high in modern road, but the fatalities per fatal crash is much higher in heritage road network. So this is the model that has been developed based on the urban road network variables. There are 21 variables. Also, apart from the quantitative values, a qualitative value of road safety audit with 13 parameters was considered, and then it was developed with the artificial neural network. And this is the model performance that has been observed. If you can see that the modern road has performed with the variables that has been identified, 21 variables, it is the performance is 0.88. That means the variability of the model is just 12%, whereas the same variable factors considered for heritage road network model, it is giving only 30% performance. The performance has abruptly dropped to 66%, and the pattern is inconsistent. It is because mainly the urban road network are exposure driven, and the crashes in heritage network are mostly behavior driven. And this is a correlation matrix where we can see how the same variable correlation is differently behaving in modern road network and in heritage road network. Like the total traffic volume, car volume, heavy vehicles, they are strongly positively correlated to crashes, but very weak in heritage road, whereas the VRUs and the crash are mostly strongly positive in modern road network, but very strong in heritage road network. So this way we can see that same parameters are behaving differently for different road network. So, and that's the key findings is that the safety performance function or the crash prediction model that has been developed for urban road network is giving a very poor transferability to the heritage road network, and it is also unsafe to use a wrong crash prediction model, and also a local calibration is needed, because in India we have when we have a vision of zero fatality, every fatality has to be addressed. So every aspect has to be considered, and especially we know using a wrong model means we are just not doing it inaccurate, we are also making the road unsafe. So while planning, we need the right model to predict the right crashes. So I would like to conclude my study that we need a study and we need a different model for different behaving roads. Thank you. Thank you very much.
Thank you, Ms. Monali, for showing us the difference between the influencing factors on a heritage road and a normal road by showing 2 examples. Thank you. Our next presentation is on shadow material vehicle, innovation for enhancing prevailing works on safety practices along Indian highways by Sharath Sharma. Sharath is a Vice President Road Safety at Cube Highways and works predominantly on traffic management and road safety in construction zones. Over to you, Sharath. 10 minutes.
It's working? Okay. Yeah, sorry. Yeah, good evening, delegates. Good evening, chairperson, and my esteemed colleagues. I know I'm the last one, but not the least one. We're going with a topic very important for us. It's a work zone safety. Work zone safety is a practices which we are following on all our highways, which we are working right now. And as a personally, work zone highways are safety is basically one of the critical parameters for the workers who are working day and night for our highways, who are trying to clean our highways. And they are more vulnerable in that context compared to the road user, because you have a behavior of driver behavior impacting them. So by this concept of shadow material vehicle, we're trying to add some enhancement to our work zone safety practices, which I will be presenting you all. So this is the content flow. So we will be showing what are the IRCs goes on the work zone safety, and what are the challenges which we are facing during these work zone practices, and what are the Indian standards going with the work zone safety, and what are the concepts which we are going, and what is the field evidence which we have collected, and which we found as a reduction parameters in terms of accident data. So we will be presenting that.
first with the data statistics. So you can see, we all know, we have seen the slides earlier also, we had about, as per the MOD stats, we had about 4.8 road accidents all over in Indian level, and comprising to 1.7 fatalities. But if we go with the work zone safety parameter, which is the major topic, so it comprises of about 2.4% of total road user accidents as per the crashes of work zone statistics, comprising of about 2% of fatalities. So if you see the 2% of fatalities in a work zone, in part of the total fatalities at the Indian level, is very much high, because we are working in a control environment, we are working in a control zone, where we have to provide that safety measures to restrict that incident, to restrict that crashes. So that's the major key limitation which we are facing. So major reasons are the insufficient enforcement by the authorities in terms of speed calming measures, poor visibility. When any road user is traveling, I couldn't see the any vehicle, any work zone. That is the things which we found as per the data. And also the traffic management, which we are looking into. So we have a design TMP's plan as per IRC. Very slow. So what are the IRCs? So as we have a standardized IRC practices as per IRC 55/2014. Now we have a revised one coming in 2024. I think we had already shared the comments that also. So as per the IRC, they basically go with a standard static layout, that you have a defined fast lane closures, you have a slow lane closures, then you have to just provide that implications there. But we have a major challenges which we are following here. So basically, there is no provisions when the workers are exposed to the environment. That means you have a various type of activities going on. So what are the issues? What are the TMPs, the traffic management you are following for that location? So that are the main things we have to highlight. We have highlighted here. What are the challenges basically? So the first challenge is what we are facing is the short duration work as unrest. Like our standard TMP says that you have to put full-fledged static arrangement of 500 meters, then you have to do your activity there. But what about the activities which are short duration? Like you have a crack sealing activity, you have a pot filling activity, which requires just 5 to 10 minutes of job intervals. So there is nothing, no defined TMP for that in a IRC standardization. Second issue is the traffic management setup exposures. The workers who are being defined to work on this activity, there is the IRC suggests you have to just prepare that TMP, but there is no system, there is no defined stages that how you have to provide that setup. At the start of when you are doing starting the activity, you're doing the tapering, and what are the method you have to follow to safeguard your workers and safeguard your road users. That is lacking in the center provisions, which we are trying to clear out. The third point is the absence of activity-based TMP. There is no activity-based TMPs like that as mentioned earlier. There is no, because we have various ancillary works going on in all our highways. We have activities of marking, studs, cat eyes, and road marking. So there is no defined TMPs dedicated to that thing. That should be taken into consideration. One of the important things is unsafe equipment logistics. We are saying that we need to provide a proper cordon of area, but that equipment, that cones, that water barriers, and that provisions that provide the visibility should be placed in that area. How we carry that logistics, there is no system for that thing. So that are the major challenges. And just giving one of the international practices which are following, we all know about the TMA, the truck mounted attenuators, which is you can say the golden standard of safeguarding and using for basically for short-term activities. So that is very much there. Yeah, sorry. So major advantages in the TMA is basically can see that it is very good for the short-term works, and it can safeguard the workers and proper provide visibility. But there are challenges in the Indian conditions for the TMA. TMA comes with a huge cost for it. TMA is not basically because we have several work sites going on our highway. TMAs, you cannot provide TMA for every small activity for small defined area. So that is the limitations which we are facing here. So, and the major factors which we are currently facing, currently we are importing these TMAs from the other part of the country. There is no manufacturing currently going on in the Indian conditions. There is no testing laboratory for the Indian condition right now. So that are the major challenges to provide this TMA, which we are going forward. So TMA remains be one of the important parameters, but for the Indian condition, we need some scalable methodology for that thing. That's why we are coming with some of the shadow cum material vehicle positions. So what are the measures we try to develop in this shadow cum material vehicle? So we did various iterations in the earlier stages. We tried to develop one of the shadow vehicles. Then we tried to develop some of the material vehicles, because that was the issues came from us. We need a shadow vehicle, but shadow vehicle is giving you a strength, but that is insufficient. There is no proper definition, no proper codal provisions that you have to provide this type of shadow vehicles, and also these shadow vehicles are covered with a plank from the rear side. So these are not very much a good visible area for any road users coming from behind. Similarly, we use this material carrying vehicles, but the workers were also using this type of vehicles. So these are the major challenges which faced during this execution of activity. So why we try to integrate both vehicles? So our concept is that the challenges which we are facing regarding the visibility, regarding the exposures of our workers, similarly the methods of the transition of the TMP are to be covered. That's why we're trying to integrate, and we got this concept of solution called SCMV, the short form. The name is shadow cum material vehicle, which is already been placed on all our highways right now, on the cube highways basically. So they're acting as a solutions for all the methods.
Sharath, 1 more minute.
Yes, sir. I'm trying to. You have to give me some time also. So overall, they have covered the major parameters which I give to earlier, that they have tried to give the continuous upstream safeguarding the workers who are trying to use that work zone. They are trying to reduce the exposure of the workers. We have established TMP with all this deployment of material vehicle in that thing, and they are commonly very easily available. Any vehicle with gross vehicle weight of 10 ton can be used as the shadow cum material. So make it more in the context of Indian condition. We have tried to make it. So these are the major stages which we are trying to cover in that area. So we are trying to basically do the shadow protection. We are trying to organize the materials. We are trying to withdraw the safer dismantling when the worker is not exposed to it. So these are the major prototype which we have covered. I have a small video in the end that I will show you in the end. So, and we also did some understanding of the visibility, because we have to maintain the stopping side distance of at least 180 meters. So we tried to see that our LED arrow segment should be visible for at least 200 meters for any road user. So we tried to place it at the driver view cabin and to make it more visible at height of 2 meters. So that was the various iterations done to get this type of arrangement here. We have also tried to make the flashing rate on different methodology, so that it's more visible to any person, that they can see that this is a different vehicle, and you have to change your lane from fast lane to slow lane when you're working in this environment. So we have done working on that thing also. These are the various modular stitches which we have done here. Yeah. Also, we have not just considered any Indian contest. We have also taken reference from the Astro also. Astros also says that any vehicle which is having any weight of 10 kilonewton, 10 ton can be used as a shadow vehicle if for any road having a speed limit of at least 60 to 80 kmph. So we have taken the problem statement from the Astro also, and we have used that practices from Astro also. So that is the reference we also use it. So SCMV operates as a shadow vehicle with enhanced hospitality. So we're saying that we are not replacing TMA, we are adding an enhancement to it, acting as a complementary solution for the small activities, small mobile work solutions. We have done the HERE assessment also, where we have done that when we were doing the static works on normal without shadow vehicle, so our scoring was coming about 20 to 25. But when we did our HERE assessment, our scoring came to 9 to 12 basically. So that is the assessment which we have done, and we have got some outcomes also, which we'll be presenting you. So there has been a improved driver expectancy reduction. So as per the data which we have collected, so 25% reduction in rear end collision observed on our roads when we are doing the mobile works. And there has been the 30 to 40% of accident reduction during our TMP arrangement by workers. So we have observed that thing, that the people are becoming cautious, and the incidental rate is reduction as per the data shared here. So just wanted to limit that SCMA is not a replacement of TMA for the high risk low duration, but it's best suited for any mobile arrangement, any semi-static work zone. So that is the best we have tried to cover in that one. But in a policy direction, I will suggest to all the dignitaries that we should have a national testing certification machine for TMA for shadow vehicles in the India level should be there. So that is the thing we have to cover. So, and also the recommendation being given by the ASTRO also. But I will just conclude with one video, and this is the thing. I think we can say that it works best and safest when we use alongside with the TMA as a IRC compliant. We are following with that one. I have one video to present to you. Yeah. Sound? Sir, I am on time now, sir.
No, yeah, you're on time. Yeah, that's right. So that's a localized
Yeah.
version of TMA.
Yes.
Okay.
Concept by Cube Highways. Introducing the Shadow Material Vehicle, an innovative solution conceptualized and developed by Cube Highways to enhance road safety and streamline traffic management operations.
So this is basically you are doing the arrangement, showing the video of that one. This is a taper arrangement which we are doing at the initial stage. Now we're trying to keep one buffer zone, because we have to keep the one buffer zone, because if any vehicle comes by chance, so we have a proper spacing to safeguard the workers and it is hitting the shadow vehicle. Now we have a stack of signboards in that shadow material vehicle which are coming out, and we are putting them as per the proper spacing as per the IRC TMP plan. This is the full picture which is coming then.
This vehicle plays a vital role in ensuring safety for road work teams and commuters alike. Smartly designed rear panel with high visibility LED arrow lights. Dedicated storage for road safety.
So this we have dedicatedly placed as stacks because whenever we see on a highway, you might have seen that the vendors are basically just placing the signboards and cone in just dumping it out. So we have a proper system because these are the issues which came from the vendors to us. So we are trying to make a stacks and to make it safeguarding into that shadow vehicle. These are for placing that tripods of signboards.
Okay, Sharath.
Yeah, these are for basic placing the signboards inside the stacks. By this you can easily just take it out the signboard, and thus your signboards are not being damaged from the edges.
I think we can wrap up. We are on 17th minute now. Yeah.
All thanks.
Around
All
7
thanks to
o'clock,
my
yeah, okay.
colleagues.
Thanks. Yeah.
Yeah, I think already done. Sorry, already done. Thank you, all, and thank you, Ira, for giving us this platform for us. Thank you.
Thanks. This was an extremely important topic on construction safety, and thanks for showing us some of the efforts by Cube Highways to at least bring in a replacement of expensive traffic safety attenuators used abroad. So thank you for that. And we have time. Thank you for all the presenters. We are at 7:05. So I don't think we have time for questions. Yeah, we can. I'm not going to wrap up because you have heard the sessions, so there's no point in me wrapping up. But we can take one or two questions if you would like. If anybody would like to ask a question. No? No questions. So, okay. So, yeah, I made some comments. Thanks for all the presentations. Sharath, yours last one was incredibly important. In Tavde Zabi's year. Last year in Kerala, one elevated highway, NHI is building an elevated highway, 12 kilometer, 45 people so far died in 1 year due to that construction zone only. So it's significantly important topic, and there are so many gaps to address this, both institutional as well as guideline and practice, implementation, etc. So if you have no questions, I will just cover the speakers, what speakers has done today. So we have first one from Ms. Ramya Devi, covering comprehensively the statistics, asking so many questions and focusing on empathy. Yeah, I'm not sure how we can drive empathy, but yeah, it is a very valid point to point out as well to the institutional policymakers. Second was on safety evaluation by Dr. Sadbir Pua, focusing on one particular road, interurban road from Faridabad to Gurgaon, on a different kind of analysis. And this is something for Gurgaon and Faridabad authorities to take up and try, and what improvements can be made on that. Yeah, that model, yes, that's right. And yes, Dr. Padma's presentation was on accident data analysis on two highways, using IMAP, using various analyses available in IMAP. She has pointed out that there are no local accident modification factors available, which is a shame actually, because we have 1,70,000 deaths happening. We have so many money pumped into design of interventions, and still we can't figure out what are the crash modification factors, which is something which we need to look into the mirror and ask why this is the case for everybody. Then we had AI crash-driven models for Heritage City. Thanks for showing the difference between a heritage street, influence of features on the heritage street and the normal road. Very informative. And then last one was from Sharath on traffic management. So thank you, everybody. Thank you. Wonderful presentation, very informative. It's sorry that we have crossed time and I have to push everybody to stop on time.
Please give a round of applause to all our speakers on stage. We want to thank them for the insightful presentations. I will request our session chair to please present mementos to our speakers. We want to thank them for sharing their knowledge with everyone. So I request you to please present a memento to A. Ramya Devi. A memento for Mr. Sadbir Singh Buwar. A memento for S. Padma. A memento for Monali Bose. And a memento for Mr. Sharad Sharma. I request all of you to please gather for a group photograph. In front of, okay, maybe you can just gather. Thank you to our speakers. We would also like to present a memento to Dr. Chintaman Bari of CSIR CRRI. He was the rapporteur for the technical session 2. I request Mr. Sigdar to please come up on stage and present him with a memento.
Let's go. Chintaman Bari ko.
Thank you to all our speakers and thank you all for your presence here. We will conclude the proceedings of the day today.
Chairman is not given because he has been already given. That's why, isn't it? So you might be having a doubt why chairman is not given. So that's the clarification. Abhishek. Yeah, Abhishek. Abhishek Chakravarti.
Mr. Abhishek Chakravarti also will be presented with a memento. Thank you, sir. With that, we'll bring the curtains down on the proceedings of the day today. Please do take some time out to visit the expo and check out the booths there. Those who have received a personal invite for dinner by Mr. Kapila should please contact Mr. Deepak, who is at the reception area. Bus has been arranged. Please get in touch with Mr. Deepak. And see you all tomorrow morning.
Yeah, the tomorrow morning session will start at 9:30, not 10 o'clock like today. Today it was 10 o'clock, but tomorrow it will be 9:30. Thank you.